Колеги, всім доброго дня. Прошу всіх вмикатися. Ми починаємо. Ми всіх вітаємо на міжнародному науково-практичному семінарі
Dear
застосування.
colleagues, good morning. So we start our seminar dedicated to application of waste and secondary products of industry in road construction. I am Artem Bezugli. I am director of the State Research Institute. And today we have more than 150 participants from different angles of Ukraine and world. These are administrations, contractees, projectors, designers, different scientific institutes, and representatives of profile and public organizations. We're really grateful to our foreign colleagues, leading world experts from ECOBA Association and scientists from universities of Poland, Hungary, Germany, and other European countries. As I have already said, we have simultaneous translation. You can choose the language. And the focus of today's meeting is the circulation economy. This is the model of economic development that foresees recovery and recycling and rational consumption of resources. This is very important for the preservation of natural resources. But the main principle is the fact that waste is a resource that can be used. So this is not the disposal problem. For example, there are a lot of different asphalt bitumen that is used, or some wastes, fly ash, quartzite products. And today, we have a possibility to use a lot of waste and slags because there are a lot of them during the wartime. And today we will talk about it. I encourage you to be very active. We have a lot of favorable conditions. You can raise your hand, you can comment. We will be really keen on your comments. And after this seminar, we will prepare a resolution and we will send it to state authorities as proposals and suggestions. So today, our seminar, we want to start it with the introduction word from the main ideologist of application of this international scientific and practical seminar. So Mustafa Mazinayev, the head of the State Agency for Restoration and Development of Infrastructure of Ukraine. Good morning. I'm not ideologist, I would like to say. We just launched this initiative and a lot of people joined us. I'm so happy that we have done a lot of this work, and I hope that we will continue all these operations. I understand that a lot of things that we talk about are not very important, but I think that you will understand the importance in general.
The fact is that different proposals were coming to us from different organizations which were involved into the use of the waste in road constructions, and not only waste, but other materials which are not traditional in the road works. I cannot lie, but you know that I have just started working in roadworks not so long ago, but I know that a lot of experts have been doing it for a long time, and it has been done for a long time already. And I know that there are a lot of people who are actually disappointed that at some point they started doing it and then they got upset, they started emotionally, and then this work was just going to waste, and they could not use their skills. But it does not mean that now we actually promise to use everything and to do it, and everything is going to be okay. Of course, we will continue working, and we will continue doing this works. In regards of the general facts, I would like to mention the following. First, it's critically important for us to continue the scientific work and continue the researches. And moreover, the practical use of these materials is even more important. We have met several people whom I have seen here now on the screen, who were bringing us the findings regarding the use of different waste. It's about ashes during the construction of roadworks and construction waste and secondary products, and recycling of asphalt and concrete and cement and concrete. And I have talked to many people who are doing some experimental projects, and actually we would like 10th part of these findings to be used practically. It would be actually a hope for everyone, and you know, it will be the indicator that we're not just wasting your time. So I would like this conference, which has started today, and our findings will be used practically. From my side, you will have my full support about it. A lot of you have my contact details. If not, Artem will share them, and we can discuss how and where we can use these materials, maybe not in the full scale of the whole country, but somewhere in small parts. Let's just try seeing how it is. So from my side, if we approve some materials and if we realize that it will be possible to use them, we will ask our services while projecting new roads and reconstruction of existing roads to have the variety of projecting and to see what's the difference in costs in order to choose certain technology and in order to actually use new technologies. Of course, it's not always easy to push out the previous technologies, but anyway, we will do the variational projecting, and we will choose what is more practical and cheaper and better. And if some technology is better in some region, and if the new technology will prevail upon the traditional one, I would be very grateful if it happens. Thanks a lot to you. Thanks a lot to get together here. Good luck to you. And I'm thankful to these people who started this work much earlier than us, despite the war. And this work is actually needed, and it's very useful. Thanks a lot. Thanks a lot, Mustafa. Thanks a lot for opening. So, of course, we are glad to see different participants of the market, people who project, contractors, scholars, and so on. So we have a unique chance to use the knowledge and experience. And of course, we have to maximum help the implementation of the best decisions. I'm calling you for active work. We will have some time for discussions. You will have an opportunity to express your thoughts. So please be here, be active. So our program has a lot of different issues. Of course, we will focus on the issues of the road construction, and we will analyze the legislation that we have regarding the use of waste in the industry, and we will talk about the possibility of using the waste and ashes and use of the construction waste. And an interesting issue which is used now is the secondary use of asphalt and concrete particles. Of course, you know that there is an opportunity to secondary use the cement and concrete. So colleagues, please, there is a chat. You can add your comments and you can raise your hand and ask questions, but I would like everyone to stick to our timing because we have a very intense program. So colleagues, we start working, and without further ado, I will shortly talk about the role of our research and scientific center in the road infrastructure, what we are doing, because we are actually supporting the idea of implementation of different innovative decisions. And it's very important for us to use and disseminate this experience. So I will start with my presentation. So today I have to say that our organization is the basic organization on the research and scientific activity of the Ministry of Infrastructure. It allows us to create the construction norms in this sphere. Of course, we are actively working on the road economy, and there is a special technical committee 307, which allows us to develop and to participate in the processes of this standardization. And we are the organization which is adjacent to the Agency of Restoration, and we create normative documents, so all the relevant versions of the document about the road industry are present in our institute. We are also the members of International Association of Transport and Road Institute, and it allows us to exchange the information with our colleagues, participate in joint scientific studies, which is very important in today's
свої корективи, вона визначила певні пріоритетні питання, над якими працює наша команда.
Different adjacents, and of course we're talking about the creation of construction norms, and of course it's the examination of destroyed constructions like bridges and proposals about their restoration, and also scientific and technical projecting and construction of different facilities. And you know that we are actively restoring the bridges with our team. And also it is the accompanying of introduction of new materials and of course the studies of our specialists. If we were talking about our legislation, in fact, within the last 3 years in our sphere, the participants of our institute created state construction norms and
До проєктування та будівництва автомобільних доріг. І також дуже великий, ви бачите, перелік.
created like that. And here you can see a list of national standards, and the list consists of 153. And they were actually compliant to the European norms and standards. So in fact, we have a lot of work. If we're talking about the legislation in the sphere of the use of the waste and secondary products of the industry in the road construction, we will talk about it later on. But now we have 30 such documents, and among them, our team created 26 of them. So here you can see that these documents include national standards, 9 of them, and different branch standards and harmonized standard of the European Union. So now you can see within the last years, these documents are relevant. And you can see that the 3 state standards were created. So we're talking about cold recycling and use of asphalt and concrete particles. Also, recommendations which were created in 2017, which can be used actively by our projectors. We have also harmonized 2 EN 217, which are about the possibility of the use of ashes. And there is also a special standard, so 104, which is about the technical conditions of the ashes and use of the ashes in construction works. As about the slag, here you can see 3 state standards. 9043, it's about technical conditions, about the slag for the construction works, and state standard 9178 and 79. That's the first document, which is about the technological aspects. That's the opportunity of the use of the slag in the construction works, and also a document which is about the tests of different materials. So I would like to say that except for a legislation, our team deals with the examination of the destroyed transportation facilities. It's very important now because our team has been actively working within the Commission on the examination of the condition of the bridges, which was created by the Council for National Security. And we are sure that tomorrow we will be talking about it at the international practical seminar, which is about the bridges. So you understand that actually our road network is not as big as the one in the European countries. So if a bridge is not working, and if a bridge is closed, it's actually critical for our logistics, for our transportation. That is why it is very important issue for us. Actually, within this year, we have collected the information about 25,000 bridges. I do not know whether anyone has collecting so much information within the history of Ukraine, but we can see that 24%, so every fourth bridge, is actually in a critical or almost critical state. So, of course, it is very important to solve this issue with their reconstruction. That is why we're actively working on entering every single bridge to a special analytical system, which has not only the information about each bridge, but has also an opportunity to plan the works at the bridges. So using different models of degradation, which are within this complex, and avoiding the subjective issues, this system is used by the agency of renovation. Of course, a lot of innovations, a lot of decisions that all of you are talking about. We can talk about them within the research and construction meetings. So, it's actually usually like that. We develop some documents and then we implement something, colleagues. It's important that innovations can be implemented by research and scientific accompanying, and it allows us to solve different issues, which are about construction and technical issues which are not regulated by normative documents and standards. That's why we're doing it. So it is possible to implement different experimental projects. The only thing is that we need the will of our colleagues. For all the participants of the market, we have created a very useful project which can be used by everyone. It's called the Portal of Innovations. So, in fact, everyone who supplies technology or some ideas can get registered here and insert some information about this technology. It's for free. It's available for all the stakeholders. And if you're not registered at this portal, you can get registered, and you can see here in this whole database what interesting things are proposed by different suppliers, because this access is available for everyone. So here you can see different technologies at this portal of innovations. So here you can see different layers from slags. Another communication project, here is the platform of innovations. That's again the project which we are doing online, so anyone can get registered and present their own product. And you can do it within 1 hour, and we can discuss an opportunity to implement this, and it's quite interesting. During the war, we have created an amount of different interesting documents which can be used in your work. And here is the album of the construction of road clothing, which announces different materials which can be used for the recovery of the road. And of course, this list is not exhaustive, so anyone who wants can join this work and add this album. This album is online, so you can see the link there to all these documents, so it's possible. So colleagues, please get involved. And also we have the album of the typical constructions of the rigid road clothing. You can also use it in your work. And we also have a special recommendation regarding the constructive decisions for the destroyed bridges. And this document was created together with other leading experts, not only our local ones, regarding the bridges. So the next slide shows that it has concrete examples of the secondary use of the materials during the bridges construction. And here you can see different schemes. And you can see that in this document. Also, an important issue is the scientific work. So our colleagues and us and Kharkiv Road and Automobile Institute joined the publications in our leaflet of the scientific works. So we are inviting every one of you to publish your scientific works. So this is a very famous scientific leaflet. So anyone who has different scientific materials, you can publish your findings and articles absolutely for free. By the way, whoever wants to see what articles are there, colleagues, please go to the website, and all the articles are available online. Of course, colleagues, we understand that now there are different times. The war is ongoing, and a lot of our defenders die, and also a lot of people die at the roads, automobile roads. That is why we're actively checking the security. You know that we're not actively doing the construction of the new road, so we cannot do the audit, but during the exploitation of the road, we do the checking. And we're doing it quite actively. So if you look at the statistics within the recent years, the amount of the road accidents decreased. We are comparing the period of 2020 and 2021. So it's witnessing the fact that the Agency of Recovery and others who are responsible for the safety of the roads have taken certain measures. So in any case, colleagues, we're always open. All our resources are open. So if you have interesting ideas, we are ready to cooperate with you always. I'm thankful to you for your attention. As far as I can see, we have 228 participants of this conference. Thanks a lot for you for writing in the chat. So we are commenting that the results of the research and scientific accompanying can be used for implementing of the innovation. So yes, of course, when innovation will be implemented, we do special researches and testing, and then we initiate the changes in the legislation. So it's the standard way of implementing the innovations, and it is important. Colleagues, if there are comments, I am here with you. I'll be here present all the time at the conference. And I suggest to pass the floor to my deputy. I have already started talking about the legislation which exists, and I've made some examples of the use of the waste in the industry. So I would like to introduce Volodymyr Kaskev, a candidate of economic sciences, professor, and he will talk about the legislation and examples of the use of the waste in the industry. Thank you. Good morning, dear colleagues. I would like to say that at the previous international conference before the war, our Czech colleagues said, fly ash, not waste. So it is in fact like this. So we need to actually change our attitude to what we are calling the waste of the industry. But if we research the history, when John Rockefeller started his oil extraction industry, he was surprised that only some percent of the waste is used, but he realized that, and he became the richest person at that time. So we have a big potential to make our Ukraine wealthy. Of course, I want to say that we have all the means for that in Ukraine. So the legislation or normative base is ready from the very top level to the down to technical documents. So let's start from the very beginning. Recently, a new law of Ukraine came into force about the waste management. Before that, there was a law about waste, and now it was purified. And now it defines the legal, organizational, and economic basis to shorten the amount of waste, and it actually regulates the list of the operations from the extraction of the waste and recovery of the waste and use of recycling. And also there is a list of the components which make it dangerous. So it's modern, and it complies to the world trends for the protection of the environment. And it complies to European values and approaches. Moreover, we also have a big number of normative and legal acts. I will not read out all of them because all the documents and presentations will be sent to you. That is why you will be able to familiarize yourselves with that. But I have to say that at our top level, that's the decree of the Ministry of the Cabinet of Ministers and other normative acts are very well detailed. And you can easily say that we have regulated normative base. And also there is a unified ecosystem, which details the dangerous approaches. And a year ago, a decree of the Cabinet of Ministers of Ukraine was detailing the use of the waste, which was used for different facilities reconstruction, which is unfortunately useful now for Ukraine. And here it is regulated not only the order of the use, but also the sanitary zones regarding the water reservoirs and the forest. So who works with waste, please familiarize yourselves with that. Going down to the normative base, here there is a number of different orders of the Ministry of the Protection of the Environment and Water Resources of Ukraine. And of course, there are orders about the road industry. In 2019, there was a big step when the Cabinet of Ministers of Ukraine said that we can use the waste in the road constructions and stimulate it. There was a new criterion implemented. Of course, there is a state classifier which was updated in spring. If we are going down another level, of course, we're talking about state construction norms, which regulate different provisions. These are special state construction norms, like projecting of landfills and slag landfills and DBN, where we say that we can use slag and other waste in road industry. If we're talking about civil construction, purely to waste, more than 90 normative documents are dedicated to them, like state standards in English, which are about the use of different secondary products. So cold recycling, use of ashes, slag, and so on. So this is all entered into the legislation, and the NDI is the leader of harmonization and development of this document. So out of 30 documents, 26 of them were created by our workers. Moreover, there are documents which do not mention in the name that they use the industry waste, but they allow, this is actually the European approach. Again, our Czech colleague said that fly ash is not waste. So it's actually usual material which they use just to add to cement and concrete in order to create different fields, for example. So recently, state standards of Series 9177 came into force. We are talking about rubble and gravel for road constructions. So all the documents allow to use the slags into the metallurgical industry. And we are not now treating them as waste. We are treating them as one of stone materials which can be used for filling. Same thing can be said about a series of the documents harmonized. We're talking about different hydraulic particles. They regulate the use of slags as the binding component. Our institute has also harmonized a number of documents of this series, state standards EN 14227. We are here talking about mixtures which can be used as a reinforcement and hydraulic and binding material. Not only in the industry and not only in the road industry. So here there are mixtures reinforced by concrete, and there are different parts dedicated to, like part 2 are talking about the use of different waste as the binding component. And state standard 305 also talks about the use of bitumen and the mineral. Same thing about the state standard 309. We're talking about the methods of experiment for the soils. We can also use here the fly ash and slag. Same thing about the next standard, also the state standards. So here we can see that in our standard, together with traditional fillers like granite and stuff, we can use other fillers made of slag. This technology shows very good results, and we have a document for cold recycling. It's the same about secondary products of the coal industry. Unfortunately, these regions cannot produce anything because the mines are in the eastern part of Ukraine. So we have just one project of the use of the secondary products of the coal industry in Donetsk. If we're talking about fly ashes and ashes and slag materials, we can say that the normative base, starting from SO 104, which came into force in 2013, was supported by the harmonized standards of Europe, which are about the fly ashes for the mixture of reinforcement. Actually, for mixtures by fly ashes, we had good experience of the use of the fly ashes before the war. We had it in Bushtinska TES road, and the results that we can see within the 2 years. My colleagues will talk to you about it. And also there was a road with fly ashes and cold recycling, 1018. So as the experience shows, this technology showed positive results. So of course, the metallurgical waste. Of course, we understand that according to different resources, we have 36 billion tons And of course, before the war, the numbers were growing, like 4 million tons were added, and these were huge amounts of this waste. And now, of course, we have even more because the heating electrostations are working right now quite intense. So, of course, our institute still has a big history of researching of how to use slags in the road industry. We're talking about furnace ones and others. In the beginning of 90s, we started using them, and now before the war, we have researched the slags of different producers, different metallurgical factories. So it showed that according to our laboratory researches, we can use them for road coating and the soil coating. And there are positive results. There are also some specific results. So you have to be very careful. You need to define their activeness and choose certain technologies. And that's our traditional one. So N31 road was covered with it. And also there is a positive experience of the use of the rubble coating. So the road T2409 road was covered with it. So this is where we used the industrial waste for road constructions. If we're talking about slag and metallurgical industry, there are even more documents right here. So these documents are updated. So of course, there are some traditional ones in here. You can see an old document of 1995. Here you can see the use of the slag for construction works. So it actually allows to use the standard, but there are also our standardized documents which are about the road works exactly. So now we have the technical conditions for that, and we can conduct the researches. Also, the document 9178, which regulates the layers of the coating with active and non-active slags. So I have to say again that the normative-based legislation exists for that. Here you can see the spheres of the use of this standard. So, dear colleagues, I have to say that the document, as you can see, exist. They are our own ones created by us. There are harmonized European documents. And we know of the rich experience of Europe. And we only need to do one thing: change our mindset regarding the waste. So fly ash is not waste. It's not only fly ash. I'm just citing my colleague. Metallurgical slag isn't waste either. So we just need to realize that it's not the waste of the industry. But anyway, non-traditional construction materials can be also used. Of course, they are a little different from the traditional ones. They sometimes have not stable characteristics. That is why the laboratory researches and clear indicators and technologies will lead us to the achievement of economic indicators, and we will also decrease the ecological pressure to our environment. And of course, we will ensure the massive utilization of the waste. Thank you.
Дякую, Володимир Іванович. Дякую вам за вашу презентацію. Ви дійсно так само робите дуже багато роботи в цьому напрямку.
You do a lot of work in this direction, and also the departments that work under your guidance, they do a lot of different important works. I know that Mr. Volodymyr today will help me to facilitate this event, and in the evening we will make conclusions. So, dear colleagues, please not only ask the questions, because for now I don't see any questions, but also give your suggestions that you have. Maybe you see something, maybe you would like to suggest something. That's it. So now we proceed, we'll go down our agenda. The next presentation is about metallurgic waste. I see Mr. Salih Igor Vyacheslavovic, the center of the State Ecological Academy under the guidance of Ministry of Environment. So, Mr. Igor, please, the floor is yours. Thank you. At first, I would like to drive your attention to the fact that it is the first time that we started to work with the State Research Institute. And as far as I understand, we have been listened to as for different our ecological programs. I know that there is also some legislative basis that has been accepted. This legislative basis has been prepared by the Ministry of Environmental Protection. And I'm so happy that all these documents are in use now. Also, I would like to say that in Ukraine, there are also new preconditions of technological acceptance. There is a new law on the management of waste based on European requirements. And also, it's very another document that is the Regulation 1073 of our Cabinet of Ministers is of great use to us. In such a very difficult time for our country, we should take into consideration all the possible recycling use of the waste and other slags. And we must think how to use them. All these recycling issues are the basics of circulation economy in European Union. And this will be also the basics of our state economy. We know that during the mining process, there are industrial waste. In dumps and ash dumps, there are 0.6 billions of tons of metallurgic waste and industrial waste. So you informed us that metallurgic slags are used, steel slags, melting slags are used also. Today, we have been done a lot of research about the slags, and the most important basics, the most important stage is the classification and making catalogs for how to use them for road constructions. This has been done in developed countries all over the Europe. I also want to mention, as for primary metallurgic and industrial use, there are also enrichment processes. Enrichment processes, what we have worked on and what will be very interesting for our conference, is the fact that raw materials that needs to be used to implement it in our works. These are sand clay mixtures and pulps. Pulp can substitute river sand as in concrete mixtures, as in motorway road constructions, and also construction of structures during different construction works. So this is very perspective question. As for detailed usage of concrete pulp, their strength, their compaction, their concentration of the pulp addition, all these issues will be detailed in the materials that I will provide with all the participants of the conference. I also would like to say that in your speech, you talked about substitution of crushed stone to the dry separation waste materials. This is also very essential. And there is a big accumulation of quartzite, crushed stones, and rubbles in different fractions after the enrichment processes. And we can use all these in the road construction. The example can be the road the first part of the road produced by the Ministry of Environmental Protection and one of the agencies of Ukravtodor. It was T2409 Grabiev-Zolotonosha Road, and indicators show the better results and outreach than laboratory testing. So I mean that field requirements were satisfied better than laboratory ones. So how have we started this scientific work? We took the waste, we investigated them, made a research, and we didn't have a goal to adjust results of our work to the future usage for road construction. These results were obtained by us through investigation, research, and laboratory testing. Also, there were a lot of consultancies. There were a lot of very scrupulous works that resulted in construction of the road T2409 that I have already mentioned. After it, with contractees, we found a lot of things to discuss. We discussed estimates, and then we made another part, T0207. These are 40 kilometers of this road, It was just mass implementation of quartzite, crushed stone, and dry magnetic separation materials after enrichment processes. That's why I would like to drive your attention to the fact that we changed approaches from contracting organizations. We have seen the movement towards ecological friendly resolutions of different issues, because you understand that substitution of river sand to waste pulp, we contribute to ecological program, to ecological protection. So these are ecological friendly technologies. And we have also saving of budget funds that are very important for Ukraine today, as Ukraine is at war. We have to recover and to use rationally both natural and resources and budget funds for our country. That's why use of mining and metallurgic waste will give us possibility to decrease the pricing by 25–30% of construction works. Also, we support the fact that the conditions of the usage of the waste should be taken into consideration, because waste in different situations can behave themselves in different ways. I intend metallurgic slags and blast furnace slags, because they can be different. They can be humid, they can be dry, and it depends. And also the fraction of metal particles from steel and blast furnace slags can also influence the quality of the roads and motorways. As for contracting organizations, I would like to say that the group of companies Autostrada, that is quite powerful agglomeration, they know how to reuse waste for different purposes. We worked a lot with them, we had this opportunity, and we want to continue such a collaboration between organizations of the Ministry of Ecology and contracting organizations. And also with our colleagues on research and scientific work from State Research Institute. Another way to use waste is the issue of gabions. Our academy made a suggestion how to use gabions that will be filled with the quartzite rubbles, and it can be also used. We have prepared gabions that can be arranged not manually with the net, but also with some reinforcement parts for strengthening the structure. And also some crawler cranes can be used. I mean that all these gabions are arranged not manually, but more with some automatic technique. We can use them while building side parts of motorways. We can use them near a river, just not to distract and ruin the road pavement by the river. And also we can use them in the bridge construction. As for technogenic raw materials, we know that now we have an issue that is under the stage of resolution on our ecological department. This is the use of acceptable ecological technologies. This is demineralization of mine waters. I think that in a month, we will be able to provide you with correspondence saline concentrate and chemical composition of salt that we can consider to use jointly with the State Research Institute for strengthening road coverage, because we understand that mining process for salt is also very difficult process, but the usage of salt after demineralization can be applied here. I also would like to say, this is my personal opinion, that if we use demineralization waterways, we can consider the suggestion to support this initiative from state budget for use of such type of waste. What has already been done? I would like to mention that the authorities, state authorities, and the Ministry of Ecology have provided all the favoring basics for creation and establishment of industrial parks on reusage of waste. Personally, I participated in the bill drafting of such a law, where we wrote that usage of recycled waste is to be done. So we can provide support to industrial parks. We can work together with our ecological academy, with our state research institute, Ukravtodor company. We can create such industrial parks that will give us possibility to diminish and reduce the price of construction and reconstruction of 1 kilometer of road construction. This was very short about essential and paramount aspects of our work. I would like to call you on collaboration. We are open to work with you, and I think that having joined our efforts, we will be able to recover our Ukraine in ecological direction, and we will be also useful for saving natural resources that we have in our country. Thank you. Thank you so much. We are ready for collaboration with you. All the suggestions that we will happy to share. Glory to Ukraine. Glory to heroes. Thank you so much. Thank you for your presentation. Thank you for the work that has been done by your specialists to provide the change in the perception that waste is not the product to be disposed, but also the product that can be reused. And you prove it practically and empirically, and doing some concrete research and scientific projects. So we will send out all the materials, all the presentations that we will have today. We will send them to your emails. You will have possibility to know in detail about these presentations, and there will be contacts of the participants that you can address if you have some interesting ideas or suggestions. Colleagues, for now, I don't see any raised hands or comments or questions in the chat. I hope that our colleagues and participants will be more active and will raise their hands, ask something, or write some comments in chat. Dear colleagues, so then we go ahead. We will have a next presentation. I have already mentioned today that we also invited our foreign experts, world experts on application waste in industry. And it's such a pleasure to see our colleagues from European Association on disposal of byproducts and coal waste. This is very important organization, ECOBA. And today we have the Secretary General of this association, Doctor of Technical Sciences, Hans-Joachim Feuerborn. He will share his experience and he will talk about the use of coal combustion products in earthworks and road construction, experience and regulations in Europe. I hope that Mr. Hans-Joachim Feuerborn hears us.
I'm sorry, please apologize my poor Ukrainian skills. Therefore I could not really follow the presentations and the issues of discussion by now. But what I heard is waste aspects, and so therefore I think I'm happy to report about a bit the European experience. I will simply share my screen if you allow me to do that. Can you please give me a signal whether you can see my screen with the first page of my report?
Так, ми її бачимо.
Yes, we see your presentation. Thank you.
Can you see it?
Yes, it is visible.
The report is about the use of coal combustion products in earthworks and road constructions. And I was invited to report about experience and regulations in Europe, which is simply the easiest way of going into the application. A short info about ECOBA, which is the European Coal Combustion Products Association. It was formed in 1990 by energy producers producing byproducts, ashes, you can call it waste, byproduct, secondary material. It doesn't matter, the material have properties, and therefore the ECOBA members, which are about nearly 90% of the European Union, considers the material valuable raw materials. So simply to keep it as neutral as possible, because the legal discussion is of no use. Finally, you can use in earthworks simply contracts, and you have to convince parties to use the material based on the material properties. So the mission of ECOBA is to inform about these issues. This report is considered to be part of this task, to inform about legal and regulatory measures and to make sure that the material can be beneficially used, and to participate on European activities, especially to make sure that the legal background is always possible to continue the material. So what we are speaking about is basically the production process, is a power plant which has a boiler, which has the dusting material, desulfurization units. When you burn coal, you produce fly ash, you produce bottom ash, you produce gypsum, so-called byproducts or coal combustion products, as we call it. When you operate the complete process, you are fixed to climate change policies. In more western parts of Europe, a bit more or very strict. In the eastern part, a bit less, but basically it's all based on the general United Nations Framework Convention, EU strategies and laws. Here we are looking for dedusting, desulfurization, denitrification, and also for CO2 reduction. But when we look to the lower part of this sheet, then we look for the material properties which are produced in power plants, which are then used directly or stocked interim. So that means when you have interim stocks and when you have materials on stocks, then you know that it is basically having the same properties as those which are used directly, but it serves as a reserve for future uses. Here we speak about key issues, which is circular economy, which drives towards increased use of this material, the Green Deal, the construction products regulations, which is the basic for regulatory background for use. Basically, all these are new keywords, but we can tell you that at least ashes are used since decades. In some countries, more than 70 years experience in earthworks and road constructions. And therefore, I think this is a good basis for sharing experience and knowledge. ECOBA is doing an annual statistic on EU 15 countries, which is the northwestern part, joined to Greece partly, which has a big reduction over the last years due to the stop of coal-fired power stations. When we go to EU 28, then we are going further to finally EU level. Also, Ukraine figures are in with about 120 million tons CCP in total, and about 100 million tons of ashes, which are partly utilized, but partly put on stock. And when they are on stock, then they are serving as a potential resource, because ashes on stock, especially for earthworks, is a source when you consider you need huge amounts of material of similar quality. Basically, a quick sketch on the production. Fly ash is always the biggest part in a power plant operation. About 60% of the total byproduct amount is fly ash. That means fine-grained material. Here we do not separate between hard coal and lignite. Fly ash, it's simply the total amount. Bottom ash, basically about 10%, and gypsum is the second biggest source to use. The statistics of ECOBA also provide information about utilization and disposal of CCPs. You can see that the disposal is about 4% of the total. That is not much. That is basically out of spec material. Out of spec means that the requirements from standards, from product standards, cannot be met. That is when you start a power plant and when you stop it. So that means then the consistency, the homogeneity of the material is not sufficient. You see also about 46% of the total is used for restoration of open cast mines, quarries, and pits. Basically, this is from lignite combustion, because lignite is mined in open mining operations, and you have to refill the ashes, so that is a predominant use. But there are also other uses which are then compiled in the utilization in construction industry and underground mining. Here we have the use in cement, concrete, road construction covered. That's about 50% of the total ashes. When we look for ashes, then we have to see what is the basis for ashes. The basis for ashes is coal, which is either imported, that are the green columns, or which is lignite-based, that are the red columns. So you see from Germany to the right into the east, you see at least most of the countries are using lignite. And countries with own hard coal mining, that is Poland, Ukraine, a bit in Turkey, which serves as a basis for energy production. When we look to the potential properties which are coming out of this, then everything what is based on hard coal all over the world is siliceous type ash, and that means it is well defined in international standards, also European standards, also Ukraine standard. It is a pozzolanic material, well known from the properties, well known from the composition, and a very homogeneous material. When you look for hard coal and lignite on the east-western side, that means that we have siliceous plus calcareous ashes. And when we look to lignite specifically, then we are speaking about ashes which, as a result, have the same properties, the same composition like hard coal ash, but it can also be extremely rich in lime and sulfur. For example, in Germany, 20% of lime and sulfur is a maximum, but it can also be as low as 3% or 7% in the ashes, and they look like hard coal. The basic difference in these materials is the lime content, which from lignite can be nearly nothing to up to 25, for sulfur from 1 to 15% compared to silicious type ash or fly ash from hard coal, where you have sulfate content up to 2% or 3% maximum, and lime contents below 10. And this is a basic issue for, you have to speak about properties. And when you have the properties, you know whether you can use a material with high lime content as a binder or with low lime content as an addition or a fill material. So basically the CCPs or the ashes are mainly utilized in the building material industry, civil engineering, road construction, construction work, underground coal mining, recultivation and restoration purposes. And the majority of CCPs is produced, meanwhile, to meet certain requirements of standards or other specifications, because we have to respect the waste directive, which is applied in all European countries. The waste directive has a waste hierarchy. The waste hierarchy starts with avoid waste. And if you can't avoid it, which is normal for coal-fired power plants, then you have to utilize it. So basically, this is an issue which has to be considered. This is the source. The source is avoid waste or use it. And for the use, we have developed in Europe a lot of European standards. We separate between harmonized standards, that means has to be applied in each European country without any change. We have non-harmonized standards, that means they are published as European standard, but it is a decision on the country, on the national regulators, whether they cite this and then it has to be used or whether they allow it to be used. On the other hand, on European level, we also speak about European technical approvals, where properties as well as application rules are defined. And parallel to this, you have also national standards, guidelines, specification, or quality agreements in the industry, which allow the use of materials in a proper way. And this is the basis, basically, for European standards, because the national experiences are compiled on European level. Which standards do we have? Basically, many of you may know them. We have standards for cement, for fly ash, for concrete, for hydraulic road binders, hydraulic layer mixtures. Last ones are basically predominant for earthworks and road constructions. We have also the standards for aggregates, for lightweight aggregates. Also here, ashes are addressed. And we have the application rules, concrete products, road construction materials, which provide the basic information how materials are used. Alternative way via European or national evaluation or formal approval, so that means a technical approval is always possible that you apply for a rule when you do more than one project. That is important. And especially for road construction and earthworks, the experience by project-specific allowances and permits is important. So that means for the use of materials in road constructions, you always have to consider transport issues. And I mentioned already, when you have ash on stock, and when the stocks are nearby the project, then it is very advisable to check whether this material can be used. So we have definitions for silicious and calcareous ashes in the first set of standards. We have definitions as aggregates in a list of source materials in a so-called CEN technical specification. And very recent, still under discussion, a technical report with alternative materials in earthworks, where the definitions of materials are in. Content of product standards, basically the scope, where can the material be used, what is the material, the properties, and information on what to declare. In the application standards, there are detailed information on how the products are used. Here it is more focused on EN 16206, but for earthworks and road construction, I will also show later on a new set of standards which has been developed, which is specifically addressing information on how to use ashes and earthworks and other materials. This is the standard series 16907, which was published in 2018, where the principles and general rules are included, classification of materials, the construction procedures, and here this, part 4 is on soil treatment with lime and hydraulic binders. And the hydraulic binders also consider calcareous ashes, for example, for soil beneficiation. The part 8, which is recently drafted, is alternative materials in earthworks. Here the discussion is on, and here are all the fly ashes are beneficially described, which we have. And we have to separate it to fly ash and bottom ash always, siliceous, calcareous, and also considering fluidized bed combustion ash. And the information or the experience with these materials in earthworks is compiled in this report, Alternative Materials in Earthworks, where you have specific material sheets in chapter 9, which provides a specific information, and you have general descriptions on technical parameters, environmental issues, because there is no project where you only consider technical parameters. You always have to consider also environmental testing, and that is the first time that on European level this has been compiled. I would like to bring a bit more illumination into this regulatory aspects, because I told already that the experience in Europe with ash use in earthworks and road construction is lasting very long. And an example was presented from Ivan Skidmore at European Experience of Use workshop in 2018, organized by DTEC, the Ring of Confidence. That is a London ring road, which is completely built of ash, because in UK there were always huge amounts of ash on stock. And for building the dams, the ring road of London was completely built with ash. Tomasz Cegilski will report later on about the Polish experience, because also Poland has ash on stock. And therefore, this is a beneficial, this is a very useful tool to do it. And we can also highlight that France, with the history, is also on. On the UK, there are best practice guides where you can download it from the UK QRA website. So they simply are old because the experience is old and it is normal to use this type of material. It is simply an economic aspect whether you take this material into account, because the basic information, technical, environmental considerations are all covered and can be done. An example freshly presented by František Kresta from SG Geotechnica is the motorway in Czech Republic. He also refers to the structure design of fly ash dams, which is given by a Czech Republic standard. He also referred to fluidized bed combustion ash as a binder, also recent example. So it's not only an old story, we have to renew always the experience in countries and to bridge. An example in Germany, where we have mostly use of ashes in bound application in cement and concrete, but also bottom ash is mainly used for bridge filling or in road construction. And the calcareous ashes are used specifically for soil beneficiation as a binder because of the high lime content. So simply always highlighting it's the properties which are decisive for use, and not in the priority the legal definition of this material. This is always a hurdle. Just a short information about the content of the report, which was provided by the Earthworks Committee. It is simply showing specific national regulations which include European regulations for aggregates when referring to materials. The technical requirements are defined in earthworks guidance documents and contractual issues for natural material, for soils, for recycled building materials, and industrial byproducts. Industrial byproducts are ashes and slags. Then we have the environmental requirements, which is the soil degree for natural soils, and we have federal regulations, which are now replaced by a state regulation. And we have technical delivery notes, which define the technical parameters which have to be given. So earthworks is a bit different. It refers to the European standard and goes on. And then here, at least for environmental issues, the procedures are described what is there. I would like to conclude to simply say CCPs are produced in Europe still by the combustion of coal for energy and heat production. We still have more than 123 million tons of produced each year, even though it is shifted in the Western European parts. It is completely down or is going down due to the phase-out discussions and decisions. In the Eastern European countries, there is still a production. And for interim, in some countries, we also had more production than expected. Ashes for road construction are also served from stocks, not just from fresh production, because in huge amounts on stock is the material basis, because it is a well-defined resource. So resulting ashes are either of siliceous calcareous nature with different reactivity and utilization options. The properties are decisive. That is the most important thing, and you have to look for homogeneity and for enough reactivity in the material. Coal combustion products are used as a replacement for natural resources, and therefore they contribute to the sustainability of construction materials. Sustainability is another key word to circular economy, which simply strives you can save CO2 in your construction material or in your constructions, and that makes your construction more green by simply using a waste, a secondary material, a material according a product standard, a byproduct, a product, whatever it is, the properties are decisive and you have to find your way how to deal with that. They are mostly produced to meet technical and environmental requirements in European or national standards. That is, when you do it fresh and you have it on stock, you have to prove it, and you have to prove the quality by process. In road construction, ashes are mostly used by national regulations. The requirements from European product standards are considered also in the national application rules. And with that, I would like to thank you for your attention, and I hope that this report is well received. Thank you very much.
Дякую. Дякую, пане.
Thank you. Thank you, Mr. Fireborn. So I will continue because Mr. Tam has been called for the ministry. So now, Mr. Fireborn, can you give me, do you understand well that 60% of ashes is used? Or do you use all the 100% of burnt ashes in this or that direction in construction? So which percentage of ashes do you use?
Sorry, I have no translation.
You need turn language.
You need switch on your channel. You need choose the channel.
No. Now I have something in. Can you please try again?
Of waste in your project. You said about you used 60% of waste for fire, maybe.
Yeah. Basically, this is a statistic across 15 countries where we have utilization figures. In some countries, we have for fly ash 110% of utilization, like in France, because they also use ash from stock. So they use much more than they produce annually. So this is only possible when you have stocks. In other countries, like Germany, for example, we use hard coal ash, nearly 100%, because we have to utilize. We are not allowed to dispose. Lignite ash is different. It goes for reclamation into mines. So therefore, also mine reclamation is considered to be utilization. And the lignite ashes are also much more heterogeneous. But you don't have it. You only have siliceous type ash, I expect.
Thank you very much. It's very important for us. And I have questions from, I am Victoria Hrudьба, I'm professor of National Transport University. And first of all, I want to thank you for your very interesting information, and it's very important for Ukrainian road building. And I am interested about environmental impact assessment in such type of project. Maybe do you have specific procedure or maybe different way about environmental impact assessment?
There is a full risk management system always required to each earthworks project, but only in the UK. In the rest of Europe, due to the process and the goal and the well-recognized millions of analysis we have shared with the authorities, we have simply to do a quality scheme considering leaching values of materials. So basically, when we look for environmental issues, we have limit values to meet. And this is the basis for use in all the European countries. That is a bit different. It's not the same in all European countries. So therefore, it is non-harmonized. But in every country, you need environmental testing. That is mostly leaching criteria for most of the metals like arsenium, cadmium, chrome, nickel, zinc. And when you meet the limit values, then you are allowed to use the material according to standards. And this is then the replacement for the full risk assessment system in these projects are doing this risk assessment system depending on what is in the contracts. And when this is given, the precondition for use of secondary material, all industrial byproducts are simply considering that these quality criteria are met, technical as well as environmental.
Thank you very much. Thank you. Thanks a lot.
Дякуємо, колеги. Будь ласка, хочу звернути вашу увагу.
Thank you, colleagues.
Зараз понад 220
I want to say that there are 221 participants. If you want to say something, please raise your hands, electronic hands, because this is very important.
Будь ласка, чи є ще
And
запитання?
you can also write in chat
Немає.
if there are any other questions.
Тоді переходимо до
If there are no questions, then we pass to the next participant, Mr. Tomasz Szeherski. Mr. Tomasz Szygalski, the floor is yours.
Hello, good morning. First of all, I would like to say thank you very much for invitation and for opportunity to share with you very shortly, essentially, Polish experience in college processing and utilization, and to invite you for deeper cooperation. I am from Warsaw University of Technology, and we are dealing with these issues, me, myself, more than 30 years. This case, including postgraduate study, different studies. I guess maybe in the future we'll find a way how to cooperate. If you accept, I will share my presentation and only shortly share just what I can do in a short time, essence of our experience. In Poland, in fact, we deal with coal combustion products since Second World War. First, we start from road construction and our experts. I guess similar time also in Ukraine, the experts, the scientists in Ukraine also start to do this research. And I guess we follow parallelly your experience. You have scientific experience and practical experience also in Poland. And we start our association, Polish Coal Combustion Products Union, in early 90s, already more than 30 years, activity for research and popularization of the knowledge about coal combustion product utilization. Also, I have pleasure and honor to visit Ukraine several times with discussion about processing ash, to sharing experience. Also, your expert visited Poland. I am really happy and I hope we will continue this cooperation in the future. to benefit both sides, and especially to support the reconstruction of Ukraine after this difficult period of time for you. And this case, that's what is essentially, from my perspective, important. It's the question of sharing experience. That's what Dr. Feuerborn mentioned. Technical standardization, sharing this statistic. It's something which is most important. We have Euro College Conference, our European forum. We start 2008, and I strongly recommend you also to take part in this activity, because this global European experience is really amazing and could bring a lot of benefit. That's what Dr. Feuerborn mentioned. Statistics is essential to know what kind of generation we have. I show you example from Poland from 2018, what kind of power generation by fuel type we have, and what kind of ashes appear, and how we do with ashes. In Poland, nearly 75% is utilized, still we're landfilling some part of ash, unfortunately. We have quite clear structure, what kind of coal combustion product appears, and according to the process what Dr. Feuerborn explained, appears different kind of substances with different kind of qualities and different kind of destination. What we do with this is also different. Cement production, concrete production, road construction, precast concrete, mining, reclamation, building material, they are principal one. And in Poland, we developed all of these technologies last 30 years in different time, in different volume, but we have available all these technologies, including also filling deep mines, like reclamation of deep mines, and different structure of coal combustion products, like generate different opportunities for different markets. Basically, also, as you see from the Dr. Feuerborn statistics, Poland is now one of the main producer of the good quality siliceous ash, and we export quite big amount to mostly to the Western Europe. We started land reclamation or improving weak soil, peat soil, and after our projects, after land reclamation, we have several investments. The project itself is very simple, and if you are interested, we can organize like workshop dedicated for land reclamation. But I would like to show you a few examples when we reclamated very weak soil, and finally, after 2-3 years of soil stabilization, serious industrial project appears. I guess this is something which is much better usage of ash than stockpiling. We have also quite experience in municipal road utilization. I guess you have also similar project in Ukraine nowadays, when we use mostly bottom mesh with addition of cement and other material for road stabilization and to produce a base. We have also good experience building like express road, and the whole cross section is made out of optimized bottom mesh. Optimized means bottom mesh mixed with river sand, which guarantee optimum granulometry, and serious projects are made mostly or nearly only based on secondary minerals. That's what was already highlighted today. We need to see these minerals not as a waste, but we call it anthropogenic minerals, something which is coming from the mankind activity, from coal combustion, And we divided this anthropogenic resources into deposits and streams just to highlight the value, the positive value of the substances, and to highlight different resources like from mines, from power sector, but it could be also from different other sectors, and mostly highlight a different quality because streams, they are fresh production and they are mostly suitable as additives for cement, for concrete, as a binder, and mostly deposits are used in the past mostly as an aggregate, but nowadays that's what Dr. Feuerborn mentioned, after recovery could be used as also additives for cement and for concrete. It means from anthropogenic resources, we can have anthropogenic products. And this kind of positive attitude and positive perception of the substances are really important. What I would like to highlight in Poland, what we did like a roadmap of circular economy, means presenting like a critical action which need to be done in country to support this kind of utilization or usage of the secondary minerals. We try to use them as a priority, means to save the virgin resources for next generation, but for us, for industrial projects, to use mostly secondary resources. And in case of Poland, it works quite well. I guess in the case of Ukraine, it could be also a good start point to discuss how to make priority for the secondary minerals also in Ukraine. We have resource policy in Poland, and this resource policy also see anthropogenic resources as a part of the resource policy in Poland, which is good in the future because it could create like opportunity for cooperation between different ministries, like a Ministry of Road Construction, Ministry of Industry, Ministry of Finance, Ministry of Environmental Protection, to make some kind of one common clear goal, secondary first. Last decades, we focused on binder production, means different kind of binder, mostly from the lignite ash, high lime ash, divided into different products, and mostly for road construction, but mostly for soil improvement. When we have very wet soil, weak soil, we could significantly improve using typical technology, just spreading this material on the wet soil or clay soil, and really improve the quality very quickly and in a reasonable financially way. In Poland, we do this project more than last 15 years, and most of the highways are improved or under construction. The soil is improved using this kind of binder. This binder also are used for flood protection when we do dikes. We have also technology which is using like a local soil, and this material really efficient. What is important, it's environmental product declaration, and the company who are doing this, they go through all this process of certification, and also the quality control. Means all the production goes like a normal production of cement or lime with national quality control according to the standard. Also, we try to make this product, we verify the environmental influence, and we measure that this kind of application saves the nature. Because the lime production, it stick with emission like a nearly 800 kilogram CO2 emission by ton, cement 700, but this binder, it's maybe 120, 140 kilogram per ton. Means it's really efficient CO2 saving. We also worked last years to apply like a Tetra Plus system, means the system for trading greenhouse gas emission reduction unit from circular project. Means all this project stick to the battery production was calculated what kind of emission and what kind of reduction happened, how much this project participate in sustainable development goals, and anthropogeneity indicator means how much secondary minerals are in product and how much are the virgin one. And finally, we demonstrated that only one company last 10 years generate like more than 1 million ton of CO2 saving. And this kind of system is verified, and this unit became part of the voluntary carbon system. Means they could be sold out and transfer into money. Also in Poland, we strongly we work to demonstrate that power plant itself should be treated not only as an electricity, heat and cold producer, but also anthropogenic mineral, like a product. This case, not treat the ash as a waste, but from the beginning, inside power plant, give him positive way as a product and improve the quality of the ash towards product during the energy. That was last slide. Just to like to say that secondary first is our motto. We try to promote usage secondary minerals before natural minerals, and this case I hope you will join this, and in your case it could be very efficient way how to participate in the reconstruction of Ukraine and how to give the chance for the power producers to have less secondary minerals, for the engineering sector to have more efficient way of doing their project, and for all of us to give the chance to save the virgin resources for the future and to make many stockpile empty. Our friends in France, in Germany, in England, they show how to do. Finally, to clean the nature and to do a good engineering project. And again, in the end, I would like to welcome for cooperation with Polish experienced company and university. Thank you.
Дякую, пане
Thank you. Thank you so much, Tomasz. I would like to say that this was Tomasz Siegelski, the Director of Engineering Center of Anthropogenic Minerals of Warsaw University of Technology, the candidate of technical science, and he talked about the experience of Poland in the processing and use of coal combustion products. I also want to ask a question. It's very interesting to know about your best practices. We see that you have worked a lot. Tell us, please, do you have any possibility now to talk about economic indicators of fly ash usage? Are there any like indicators how you use it? For example, experience on some project or something like this. How do you use fly ash?
Thank you very much. This is a very difficult question because depends on the power plant, depends on the quality of ash, depends on the final user, depends on the technology. But I would say that in Poland nowadays, all the ash are sold out, fly ash, via tenders, and price of the fly ash for last tender was like a 20 euro per ton. Means the ash costs huge money. And I guess in the Western Europe, the price of ash is even higher. Good quality ash, the price is even higher. This case, yeah. But it's very individual. It's very, very individual.
Я так розумію, що Україні пора транспортувати.
Yes, thank you so much. So, okay, we can transfer fly ash to our European colleagues. We have a lot of it. Dear colleagues, please, if you have any questions, please ask them. I don't see the questions. Then, thank you so much, Mr. Tomasz.
Thank you.
Loud.
And now we go to the next. Mr. Zsolt Bence, the head of the laboratory of the non-profit organization Institute of Transport Sciences. I'm sorry, there was a question. The Joachim Fireborn wanted to ask the question. Please, if you hear us.
It's a question or a comment, because I think looking for finances, it's a real issue. Basically, you need quality improvement because what you have on stock needs to be quality proven. This is cost. This cost is to be paid by someone. You have to pay third-party control. This has to be paid by someone. So speaking about the blue boxes, you can earn money with Ash. I can only warn, don't start with this. Simply start first with the properties, consider the good experiences, and simply evaluate a realistic approach in your country for your situation for this project. At the final end, it's a transport cost to the site, which you have to consider, which is the most important one. So for contracts, it is an issue whether you calculate X worth or at the site. So basically, transport is the biggest issue with this, and I think the aim should be to use material which you have available. And I think our mission is to simply share the experience that materials can be beneficially used with it. So therefore, I can only warn. I know about the wishes of parties to earn lots of money. That is all correct. It can be done, but it's nothing for the public. So we are working normally in committees where at least speaking about prices is not allowed. It is also not wise because it is very much depending on the specific situation. And therefore, I think it's less stress when you simply see it's a value product, but quality parameters, quality evaluation is also cost consuming or producing cost. But finally, I think it's a situation which you have to consider based on the transport distance to the site. I think what you do with the ash processing or something else is comparatively low to at least the transport distance at the final end. So that was just a short comment to that. Apologies and thank you for bringing me back to the scope.
Дякую. Дякую.
Thank you so much. I have seen also the text from chat. So I will try to read it. This is thank you for presentation and thank you to the Poland and Polish people for the help and assistance to Ukraine. Thank you so much, Mr. Tomasz. Now we pass to the next speech. The speaker will be Mr. Zsolt Bence, the head of the laboratory of a non-profit organization, Institute of Transport Science of KTI, candidate of technical scientist from Hungary. And he will speak on steel, slag, and road production on highways, plastic waste in civil construction, concrete waste as a second raw material for roads, bitumen and asphalt concrete modified with rubber in Hungary. So please, Mr. Zsolt Bence, the floor is yours.
Thank you very much. Can you see my presentation?
Yes.
Okay. So, welcome everyone. My name is Zsolt Bence. I'm a senior researcher in the KTI. And in the next few minutes, I will talk about the secondary raw materials usage in Hungary. In the first part of my presentation, I will speak about the current situation regarding the stone materials and the secondary raw materials to replace them. These amounts are mined in every year in Hungary, and in any case, we consider them 100% recyclable, like the secondary materials that can be used in road construction, also 100% recyclable. In some regions where there is no adequate quality stone material, but there is a faulty political decisions like Dunajváros, we have a large amount of industrial byproducts. Their usage
But we can see the first slide and
I'm sorry, we can see only the first slide.
oh, sorry.
your presentation maybe.
Okay, then share screen. You can see this one.
It's perfect. Thank you very much.
Okay, then okay, it goes to the next one. Okay, so the domestic and the European regulation made this possible, and they could come under the scope of the construction products regulation. You can see a regulation, the standards we speak about, and the documents on the right side. And this opened a very wide market for the metallurgical byproducts and fly ash in Hungary. Nowadays, it is a completely natural road construction material in these areas, in 4 areas in Hungary. The second part is my presentation speaks about the plastic waste in road construction. If we speak about the plastic usage, there is 2 methods. The first is an additive solution with the help of which cement can bind to plastic so that concrete products can be made from it. Before last year, there is a test section with a hydraulic binding layer was completed, which fulfilled our promises. You can see the complex compressive strength volume at the bottom. And more sections are expected to build in the next year. This additive is protected by patent, so if anyone interested in it, then I will send the patent owner's contracts information. The second solution is that we extrude the plastic waste and shape it. These solutions are primarily used for traffic safety elements due to their environmental resistance, and you can use it, and you use it in Ukraine as well. However, some manufacturers have come up the solution that make it possible to replace wood as building material, like biasing weld mesh columns. And during the experiments, we also observed the feature of these columns of fiber material that they can almost perfectly cause even the large cracks that developed after the load has been removed. So it is perfectly for the wide columns, wide mesh columns by the motorways, by us. Very short presentation about the concrete reinforced, concrete raw materials as secondary materials, because it by us 100% usable. And according to the European standard and the Hungarian regulation, it's a common use nowadays by the road construction. And the last one is rubber bitumen and asphalt. It is highlighted by us because it is patented by the MOL and is patented since 2013. And we use it as a standardized method from 2018. So based the experience, we have a regulation for that, like a normal bitumen and polymer modified bitumen. And we constructed the first section 10 years ago, and we have built more than 100 kilometers with these bituminous binders. And you can see the properties on the right side. And if you speak about these sections, every 2 years we make a report from that behavior, because it's very important for the Hungarian oil industry. But there is a dark side of this chemical stabilized rubber granulatum, because if you use it in an asphalt mixture, you have to clean it after that. Therefore, nobody is interested in the mixture plant that use it, but the state is another part of the business. So that's it. maybe I was very short and very clean. Have you any questions?
Дякуємо, колеги. Будь ласка.
Thank you so much. So, dear colleagues, if you have any questions, please, I invite you to ask them. You can raise your electronic hand, you can write in chat, because if you do it manually, like if you raise your hand, there are a lot of you, there are 200 of us, so I can't see everybody. Please raise your electronic hands or just write in chat. Mr. Zolt, I have a question to you.
Okay.
Oh, I see, Mr. Joachim, Mr. Fireborn, please, your question.
Oh, I can also wait until the first question is done. I'm sorry.
No.
Yeah,
You first.
I remember a European project with rubbers as aggregates in house building concrete, and of course a flexible aggregate is always nice to have to see, but I do expect this is all based on specific approvals. I think that is just a trial phase by now when I get it right. So that means the rubbers by now are not integrated into aggregate standards.
We speak about two different things.
Okay.
Right, because the rubber is modified for the bitumen, not for the
bitumen.
Okay.
Sorry.
Yeah. But we use shredded rubber to the embankments. So there is a shredded pieces, maybe 20 centimeter long, and this is for the frost layer, for the very low volume roads. I can send to you some pictures about it. In my opinion, it is not so environmental friendly, but we try.
So, yeah, to be honest, I think I'm active in this technical committee 396, where we have compiled the experience, and I learned about experience with rubbers, rubber packages, which are used for the embankments for roads, where I simply said, okay, what is possible, but also crushed glass. So, for example, the experience in Europe discovered in this technical report, which is just under discussion, and so if parties would like to see, I think it can be done directly next year when it is finally released.
Thanks.
Thank you.
Дякуємо, пане Йохим.
Thank you, Mr. Joachim. Then I would like to pass to my question. Can you tell me the experience of using rubber for modification of bitumen? Do you use it? Is it possible to use? So you used this rubber from wheels, from tires, or did you take some other waste of rubber?
No, we use the normal rubbers from the tires. So there is a patented solution to make it perfectly for this usage, but it is patented. So I know there have to make a mixture in it.
Якщо два слова.
Yeah. So it's.
Вона тільки подрібнювалась чи ще
So it was only ground, milled, or it was processed also?
Ground,
so we don't talk about patent.
Да, додатково.
And this is the
Добре,
patented.
дякую, будь ласка. Да.
Yeah.
Колеги, ще, будь ласка, питання.
Thank you so much. Dear colleagues, do you have any questions? Thank you so much to our colleagues, foreign experts. Thank you so much. You can stay with us. You can hear the interpretation of all the presentations that we are going to listen. And now, thank you so much, Mr. Zolt. And now we will pass to the next presentation of Mr. Stefanovich Yegor, the chairman of the board of the Public Union, Ukrainian Fund of Energy Efficiency and Energy Saving, who will talk about the use of geoinformation technologies on Novogis Hub for modeling and forecasting for the restoration and development of the building materials industry. Hello, my dear colleagues. I am really very happy to see all of you. I'm so happy to see you. This is very important, the topic that you talk about, especially recycling. This is one of the main trends, especially for Ukraine. Especially for Ukraine, where we have a lot of ruinations today. And these ruinations we should process, we should recycle. Recently, we had a meeting with Olena Shulak, the head of project committee, and other participants and representatives of authorities, and we also talked about it. I am so thankful to all the participants that have already talked, and also for the future speakers that will talk about their topics. We are the public organization, the Ukrainian Fund for Energy Efficiency and Energy Saving. Before war, we talked about energy efficiency, but since the outbreak of full-scale invasion, we enlarged our project, and we have prepared our project that calls recovery. Why it is called ONOVA, recovery? Because we see that a lot of things have to be recovered and restored. So it must be not only recovered, but also updated. And this concept of this update, it must be dedicated to the recycling. I will show you the short video that about what we have already done, and then I will talk about how we can proceed in the discussed issues. So here we are. You can see my screen, I hope. Okay, let's start. So the League of those who sees Ukraine in future and has already started to restore it. ONOVA is the public platform that unites, invents, implementing partners, donors, mecenates, territorial communities who work jointly in energy-efficient housings and spaces. Our joint aim is to update and to restore territorial communities. We have ONOVA this hub. This is the center and the headquarters of our project. This is the instrument of fixing the projects that are stated on the platform. The system is certified by international security companies. This is a closed part and public part. Ministers and territorial communities have joined us. I mean, those territorial communities who suffered from ruination during the full-scale invasion. Each territorial community can insert here information about the ruined objects and the level of their ruinations. Then, project plans and master plans can be done for different regions. Each project has separate page, the list of participants, and also a new master plan certified and tested with the authorities, local authorities. So here we can include each settlement, each participant, so on. So, dear colleagues, this is the demonstration of what we have already done. This is our joint project with the Ministry of Recovery and Infrastructure of Ukraine. Also, we collaborate with the Agency of Restoration to make a geoinformation service. This is free service. This is technical assistance. what it can do, how it can help us when we talk about our topics today. Again, I will share my screen, but this will be about presentation. Do you see my presentation? I hope yes. Yes, we can see it. So as for partners and as for what we have already done, we have talked about it, that how we collaborate with territorial communities, with ministries, with joint projects for recovery of infrastructure, military ones, infrastructural ones. So we do modeling and foreseeing for the further elaboration of master plan, how to use recycling in road construction. Here we can suggest you the analysis of raw materials, analysis of recycling plants, analysis of requests in construction materials or recovery projects, foreseeing of cost efficiency and the high technological models and levels in such during such panels and checking out the further implementation. That's why if we take into consideration these models and projects, I want to say that we already collaborate with the Agency for Restoration. And as for this direction, guided under Roman Commandant, we have talked about additional layer for passport of roads, and the process of the restoration included the recycling. So we collaborate with you constantly. Thank you so much to the State Enterprise, State Research Institute for your initiatives and for your work. I suggest you further cooperation. If you have any questions, I will be happy to answer them. Thank you, Mr. Yegor.
Зараз хвилинку.
Відкривається.
Є. Якщо можна на повний екран тоді. О, добре.
Can you
Дякую.
please
So
share
it's
your
possible
screen
full
and
screen,
make it a
please?
full screen?
Значить, що хочеться сказати?
Okay, I just want to say the following. Our
institute,
within a lot of years of its existence, has been working on the issues of the creation of construction materials and products
Відходів не можна казати.
and waste and secondary products. So the problem is known. The problem was the following: unstable composition of the fly source, because of which it was not possible to legalize the use of the waste. So here is a problem. 100 million tons of waste is going to happen after the war. So now we have a decree of the Cabinet of Ministers number 1073. And the workers of our institute mentioned the list of the materials which can be used, and the destruction waste can be used, but for that we need the researchers, and we need special legislation document which will regulate the use of this in the construction. So when we're talking about the destruction waste, we are talking about not talking about the waste of plastic and glass, because I know that there are a lot of companies which collect this waste and recycle it, so there is no problem of that. But we're talking about solid waste. We're talking about concrete, ceramic, and silicate brick and others. So this destruction waste can be used as the fillers. And the aim of them to be used as fillers, not to make a better quality of construction products, but we understand that the quality indicators will be less than the materials produced from the natural materials. And there are even issues with the costs, because if you pass this destruction waste for free, taking into account the costs for their sorting, it might be even more expensive than the natural resource. But we cannot just allow ourselves to forget about 100 million tons. So first researches that we have done and first samples that we have collected, and the analysis of the international experience, even episodic ones, exists. So it showed that such construction materials could be created and could be used for construction. What are we talking about first of all? First of all, we're talking about the need of the implementation of this project. And this project can be implemented within our institute. The duration of it is up to 1 year. Of course, we need certain financiation, certain funding, and the following stages will be included. First one is the list of the destruction waste, which can be recycled into the construction materials. And second one is the resort of all the peculiarities. So actually we can sort separately concrete and silicate brick, and we can make it whatever fraction. Then we should take these monomaterials from the destruction object, and we have to do different researches like chemical ones to define the chemical safety, radiational safety, and then the main indicators are like strength and ability not to be frozen. So if we sort the ceramic brick, there is gonna be different years of production, different strength indicators, and of course the influence of the projectile or fire and so on, which will not be a good component too. So we need to analyze a lot of things in order to define what are the ranges of the quality indicators of the source, and then try to define the recipe. So we can think of four types of recycling. So first one is the barrier bricks. These barrier bricks can be used to organize, to construct barriers. We cannot hang some furniture on them. They are quite rigid to freezing temperatures. So that's the easiest thing. So I can demonstrate at the end of the presentation the samples that we have. The second one, we think that there is an opportunity to create the fundament. So these blocks can be used for constructions of low levels, of low, not many floors. They will not be residential buildings. Next one is dry construction mixtures. Actually, they have high demands for the quality of the fillers. Moreover, they have to be ground very well. Next one is so-called FEMS, so the tiles. They are concrete-shaped paving elements. There are certain demands for quality, but there is an opportunity to create high quality. I apologize, you do not change slides. Yeah, it's the same slide. I do not have a lot of slides, so... So, what do we suggest to do? After we make the researches of the raw materials, we do some tests for frost resistance, water resistance, and we need to do that, changing the composition of binding materials, composition of fillers, using different regimes of treatment like vibro treatment and stuff. And then create the catalog of recycled building materials and to create basic ways of production. So, of course, this catalog will be available. It's going to be updated regularly by our institute when new researches will be done. And the fourth stage is the preparation of unified standards, state standards, with the requirements and methods of the control of the quality, the conditions of their use in the construction for the designers using the state standard to have all the information without checking the specialized state standards. Moreover, recycled building materials might not correspond to the state standards already existing. Who will be the target audience? First of all, local and foreign producers of the building materials, and also there are a certain amount of producers who would like to produce such materials. Moreover, to solve the issue of recycling, we will have to create some legislation requirements in order to use this building materials. We might need money of local budgets and other funds, so the catalog should have a list of absolutely certain building materials. So what will be included into this catalog cannot be said now, because we will need to organize different researches. There are now some businessmen who are ready to organize experimental factory of such building materials. Why we need that? Because in the laboratory we can make certain examinations and certain experiments, but in order to know the net cost of such materials, we will need to do that. We'll need to actually create them. So whatever is used there, of course, will be very useful. So this experimental factory will be a good base for everyone who wants to produce such experimental building materials. At the moment, such a factory can be opened at the border of Nikolaev and Odessa region, of course, provided that there is a request for such building materials and funding. So, of course, whoever will be interested in the recovery of Ukraine will need such building materials, and of course law enforcement bodies will be also interested in that, because in fact now the destruction waste is used to replace the natural raw materials. Of course, it influences the quality, and there might be some problems with that. And construction companies might be also their target audience for that. So there is a big need to address a number of funds, foreign funds. There is a support of the Ministry of Economics, Ministry of Infrastructure. Natalia Kozlovska knows about these issues. And there is only the issue of the funding. So here you can see my contact details. So whoever wants to talk to me, we're planning on creating a coalition of all stakeholders, and we want to cooperate with each and every one of you if there is a need. And finally, I would like to show you what we have already done. You should switch off this sharing of the screen and then switch it on again. I need to switch on the camera again, but I do not know how to do that. Your camera is on, just switch off your presentation.
Дякую. Значить, що
Yes, switched it off. Okay, thank you. So here is an example of the recycling material of the barrier block. And it's a cement base. So the strength indicators were not very high in the first sample, but
з режимами обробки і можна
first
виходити на
steps
результати. Є аналогічні зразки із ніздрюватих бетонів. Ну, ось даний зразок надзвичайно легкий.
and then the results will be better and better. So, of course, a thermal isolation components will be better and better. So, of course, they're all different as for the thermal conductivity, water absorbing, and frost resistance. So there is a big perspective, and I will be glad to cooperate. Thanks a lot for your attention. Thank you.
Дійсно, зараз у нас такий час, що цих відходів дуже багато буде, да?
Yes, indeed, there's going to be a lot of such waste, and it's good that you raised this issue because now it's quite relevant.
Доєднаємося, тому що зараз
And we have all continue going forward because unfortunately there's going to be a lot of such materials that will be needed to be worked on. Of course, you are welcome to ask your questions. Yes, I can see our foreign colleagues too. And now I would like to say to everyone that you can either raise your hand if you want to ask something, or you can write it to the chat if you wish. I do not see any questions now, so thanks a lot. In fact, the issue is serious. Yes, Joachim, please.
Yeah, thank you very much for the allowance to not really address a question, because it is just for information sharing. In Europe, the issue with construction demolition waste is regulated. There is a lot of experience with low amounts of recycling demolition aggregates or aggregates from recycling and demolition waste. So after the process of sorting, of crushing, of making a specific grain size distribution, this material is considered a normal aggregate and used in a certain amount in concrete mixes. The examples which we have shown, I do expect that it is mostly for thermal insulation material, which is okay, because for house building and civil engineering structures, I do expect that it's not very amazing. You need a dense structure. So therefore, one information, the European standard EN 206 includes also recycled aggregates. And on national level, the rate of using recycled aggregates is increased to 50% in mix with natural aggregates. So this was already a step from 35 to 50%, but it needs proper sorting and quality assurance. One question, perhaps, the examples you have shown, was it only for thermal insulation, or was it also for civil engineering?
Якщо це до мене було питання, то прохання перевести.
Дякуємо. Пан Андрію, ви чули, да?
If there was a question to me, then I could not hear. Can you please translate it? Yes, please switch on the Ukrainian language. Yeah, there was a question regarding how to use it like an isolation material or as the construction material, like the main one.
Використання їх
The issue of using as the isolation material is very difficult and not very visible, because we understand that in glass materials the thermal conductivity is much higher. So the issue of using it as isolation material will not be considered, but at the moment we're considering as using them as use of dry mixture, dry construction mixture, and using them as a concrete shaped paving element. That's, I think, it. Thank you.
Ще питання?
There is another question to you, please. No? No questions? Dear colleagues, like Artem said, the use of the approaches of the industry and secondary products is the constant topic of the researchers of our institute. I would like to pay your attention to the material which was forgotten, and it actually proved to be very effective, and you can make it a very good material. That's an alkaline binder. Unfortunately, my information is not changed. Earlier, the workers of our institute worked with the data of state cadastre, and these catalogs have the information about the location of the stone materials, and actually the territory of Ukraine was divided into 5 regions: northern, eastern, central, west, east, and southern. And this catalog has the information about the existing materials like limestone, sandstones, granite, gabbro, and so on. So these materials can be used for road constructions, and you can use them as stone materials to organize the road coating with no reinforcement, but you can also increase their components with different types of binders. And you can use inorganic binders like cement and the lime and slag alkaline binder that we will talk about. You can use organic binders like bitumen, bitumen emulsion, and formed bitumen, and complex binders like cement plus bitumen emulsion, and cement plus formed bitumen. And I would like to pay your attention to the creation of a slag alkaline binder. And it also includes the industrial weight. So slag alkaline binder are hydraulic binders produced by mixing ground granular slag with solutions of alkali metal components. Components of stone materials strengthened by SHEV. So it's the screening of stone material, blast furnace ground granulated slag, and aqueous alkaline solutions. All these materials were used as the materials of the grain component or close to the grain component. And as alkaline binder, we use ground fuel granular slag. And actually it had 70% of glass phase, And the Sodaluzhny fuel had 70% of soda and other components, and that's actually a good solution for the water. So we had a task to investigate the influence of the type of aggregate on physical and mechanical characteristics and deformality. Second one, to investigate the physical and chemical process that occur in the contact zone of this alloy, and to determine the technological features of the preparation of concretes. And the fourth one is to develop rational constructions of rod clothing from such materials and create recommendations for design and construction of layers from these materials. To define the composition of alkali concrete on different fillers, we used different stone materials, and here you can see the information about it on your slide. And actually the ground slag was coming up to 25%, but as the results of the researchers showed, when the granite component is 15% and it was going down, and soda was going down after 10%. So it is 5 to 6%. The researches of kinetics showed that slag concrete on granite aggregate is up to 90 days. At the same time, slag alkaline concrete on limestone aggregate is up to 28 days, like the cement and concrete. And a relative linear elongation. Slag alkaline concrete coefficient of linear expansion at a temperature drop of 40 degrees Celsius to 3 times smaller. The researchers of the contact zone of the mineral binder showed that the contact zone with the granite goes to low basic hydroaluminium silicates. So there is a hydroalumosilicate and slag alkaline concrete on limestone aggregate, low basic hydrocarbon silicates. So they ensure reliability and durability over time. And that was done by the institute in Kiev. And of course, it's understandable that the materials which can be used as construction layers of the rod coating have over time tension from the cars which are passing by. So of course we wanted to combine and compare the results, and here you can see that slag alkaline binder mixtures are much better resistant to short time pressure. So here we can see that such a material can be more durable than a regular material reinforced with concrete and cement. The study of the technological factors, we were researching the time of the preparation of this mixture and the degree of compaction and introduction of the alkaline component in the form of a solution and powder, the time interval between the preparation of the mixture and its comparison from 2 to 48 hours. And the results shown that a longer time interval between the preparation of the mixture and its composition implies a softer technological regime, and that we can work with this material. It allows to transport the mixture for long distances, mixing and compacting mixtures after a break in the work of the rollers, and correct the unevenness of the surface of the layer without significantly reducing the strength of the material, and possibly introduce an alkaline component in the form of a solution and powder. So, of course, we can use traditional technology, which presupposes the movement of this mixture to the rod, and rod transport and distribution of blast furnace ground granulated slag by cement truck. And we can mix this material, and we can get the optimal water component. And there you can see on the picture the removal of the stone material to the rod and its distribution by mortar grader. And of course, we can use regular roller, and after that, of course, it would be good for a hydration process to put the bitumen emulsion to protect the layer and to ensure the hydration process. Of course, we can use the modern technologies. I'm talking about the arrangement of rod clothing layers, materials manufactured in the installation. So, of course, some equipment allows us to better implement this material. So that's the special amount of water, and in this way we can use this material. So we can make a conclusion that the binders of different composition and strength with the slag alkaline binder can be an effective material possible to use for a rigid rod clothing. And of course, there were special experimental pieces of rod constructed from this material in the Zaporizhia region. And we have albums and constructions of rod coating using the local materials and their production waste. So these materials were used in the proposals which are shown in these albums. That's it from my side. If you have any questions, I'm ready to answer them. Thanks a lot. Colleagues, please, if you have any questions. Yes, please. Yes, Mr. Andrew. Please tell us, in Ukraine, does anyone produce slag alkaline cement? We have a research institute working on that, which is Glukhovsky. What about the production? I know about the institute, but what about the industrial production? Well, I actually wanted to remind you of this material. It was actually forgotten, but it's easier to work with than with the cement and the concrete. It restore hydration ties, and it does not lose its features with the time. That's why I actually wanted to remind you of this material, but unfortunately it's not used within the recent years. I support you. It is the material which was forgotten. It actually is used in the whole world, but Ukraine, who created it, does not have any the production of it, because now we are actually losing it. But now I think that since we need the to start the reconstruction process, I think that we just need to remind everyone of such materials which can be used for reconstruction. Thanks a lot for your attention. Thanks a lot. Please answer the questions in the chat, but we will answer other questions at the end of the seminar. So if there are no other questions, then we move on to another speaker. That's gonna be Ivan Kopinets, head of the department of bitumen binders and asphalt and concrete, who will talk about the use of the waste in the industry. Hello, dear colleagues. I will be talking about the use of the waste in the industry for going with the asphalt and concrete mixture. So we're talking about the mixtures. We're talking about large binder, fine binder, and bitumen binder. So it can be used as asphalt and concrete mixture. In fact, the modified binders can be used as adhesive, polymeric, stabilizing, and the natural bitumen and the rubber rubber pieces can be also used in that. So we are talking about rubber crystals, rubber crumb. Rubber crumb is the result of the grinding the tires. So rubber crumb from 0 to 0.2 millimeters. Then it's produced into bitumen, and it can be used as asphalt and concrete mixture, and can be used for road coating. So if we're using the rubber crumb, we actually reinforce the qualities and thermal conductivity. Of course, the rubber crumb is much cheaper than polymers, so the price is less than using the polymeric fillers. And the third one is to increase the ecological state. If we're talking about the secondary polyethylene, you can use the polyethylene of the high pressure, the one which can be used to produce the film, and when it expires, they can be collected, recycled, and secondary polyethylene can be used. In our research, the secondary polyethylene and rubber crumb were used to modify bitumen and to modify asphalt and concrete. In the first case, the secondary polyethylene was added to bitumen with a temperature of 175 degrees to 185, and then within the 3 hours, the temperature was 190 to 200 degrees Celsius, but the time was lessened to 2 hours. So if we wait for 3 to 4 hours, then the peculiarities of the bitumen changes. So modified bitumen was used with rubber crumb. So dry technology was used, and more exact. Here are the results. Bitumen with the secondary polyethylene. So here you can see 1 to 4% with the increase of the amount of polyethylene, and here you can see the decrease of the penetration of the bitumen. And also there is also an increase of the temperature of softening. And as you can see here on the fourth one, the secondary polyethylene increases the elasticity, but it is not allowed to get the bitumen according to the document. So additional researches were made on the complex modification of bitumen by the secondary polyethylene, and here you can see the secondary polymer, and half of it was changed for SBS type. So within the use of these approaches to modification, the indicators of penetration and the temperature of crumbling. So here is the difference in the indicator of elasticity. So here you can see 21%, and the change of the secondary polyethylene to polymer SBS type, the elasticity goes up to 58%, which allows the correspondence of bitumen to the requirement of state standards 9833. So here you can see that the secondary polyethylene can be used in modifying of bitumen in a combination of polymer SBS. Further on, since there is a secondary polyethylene and polymer additives SBS type, here is the increase of the temperature of softening and the decrease of the penetration, which witnesses the decrease of the binding feature. So it was used to make the asphalt mixture more dense. So here you can see that the needed temperature goes up to 15% when you are mixing it with the needed material, and then this increase comes up to 12 degrees. So so within these temperatures, the samples of the asphalt and concrete were created. So here you can see the temperature with 20 to 50 degrees Celsius. So in this case, you can see that thanks to the optimal temperatures of the creation of asphalt and concrete mixture, you can see the introduction of the secondary polyethylene. It does not influence the medium density. And here you can see that the density is the same. During the dry production. And there you can also see the strength, and the results. For the asphalt and concrete with the secondary polyethylene and other complex of additives. Here you can see the results of the strength with 20 degrees Celsius and 50 degrees Celsius. And here you can see the secondary polyethylene into the mixture. So here is the bigger strength with 20 degrees. Here you can see the modified rubber crumb results. So you can see the same trends as with the secondary polyethylene. You can see the same basically results of the elasticity. Rubber crumb allows more elasticity. If earlier it was about 20%, now it is 20% of elasticity. As for the asphalt and concrete, here was a disadvantage. We did not define the technological features. We used the same temperature and creation of the samples, which allowed us to decrease the density of the asphalt and concrete. So here you can see the indicators. With the temperatures of 20 degrees and 50 degrees. So here you can see the modified bitumen and regarding the result, you can see that rubber crumb can be used to modify bitumen, and you can increase the properties of asphalt and concrete mixture. But to use it in a full scale, we need to implement special research areas in order to move forward to the full-scale use of it. Thank you. If there are questions, I'm ready to take them. Now I can see there are questions in the chat regarding the presentation. Thanks a lot, Mrs. Irina. We will think about it. And the second question is, was the all rubber crumb diluted during your experiments, depending on the size of the rubber crumb? Here you can see the results of the sizes between 0 to 2 millimeters. It was not diluted. At the same time, it's swallowed from time to time. In case of smaller fractions up to 0.5 millimeters, so visually the particles of the rubber crumb could not be seen. Thank you. Okay, colleagues, if there are any questions, you are very welcome. Thank you. Then we move on to our next reporter.
We will talk about fly ash as alternative filler for resurfacing asphalt roads. The speaker will be Alexei Sokolov, the head of Bituminous Benders Laboratory. Hello, dear colleagues. I will share my screen if it is possible.
Це нормально, да.
Tell me if you can see it.
Да. І врахуйте, що нас перекладають, тому
Please be aware of the fact that you are translated, so please mind your pace. So, fly ash as alternative filler for restoration of asphalt concrete roads. In Ukraine currently, we have 15 thermal power plants, more or less, that are functional. So can you see it? Is everything okay with the presentation? Okay, thank you. So these thermal power plants, they are functional, they work, and they provide electricity. But there are some ecological issues. This is pollution of groundwater, allotment of large area for ash and slag storage, harmful impact on the ecosystem of animal and plant life, and probability of ash slag dams breaking. So this is harmful for ecological situation in Ukraine, and there is need for addressing these issues. I'm sorry, just a second, I have a technical issue with the computer.
це перший слайд, Олексій, ми бачимо.
Now we see the first slide,
Да, можна
second one,
запустити.
third one. In the world, ash materials are used very much. This is Japan, European Union, China, India, USA. In Ukraine, the use of ash materials and waste materials is the least. It can be used as additive for concrete, for cement, and in road constructions. But I would like to talk about the asphalt concrete mixture. There have been done an investigation and research of ash waste and mineral powder in asphalt concrete mixture, and we have stated that the dump ash, fly ash, cannot be used because it doesn't meet the standards of national regulations.
Да, ми нормально бачимо табличку.
So fly ash, oh sorry, fly ash is like a mineral powder with calcium. We have done a lot of different analysis, spectral analysis, oxide and elemental composition has been stated for fly ash. And we can see that there are some concentrations of oxides, but in general, it is in the window of tolerance. If we see the full profile analysis and the full profile calculation of radiographs of the investigated fly ash, we can see that oxides are the last part, but quartz, malite have biggest share. So these minerals can be used in asphalt concrete. That's why in 2021, an experimental section with a length of 900 meters was built on the access road to the passage of the first block of Burstinska thermal power plant. So it had two constructions. The first construction was the decomposition that you can see on the left. So with 5% of fly ash, the second construction was of the same composition, but under it there was already existing construction. Here you can see the construction works. We were present there, and we saw and followed all the works. And the next day, we made sampling After the sampling, we provided results. We wanted to determine the grain composition of the material part of the mixture. We see that all indicators are in the window of tolerance, and you can see that the asphalt concrete has been made completely from the materials showed. I'm so sorry for just some delays in speech, just because I have some technical issues with my computer. So as for slide, now we see the results of research. Yeah, so here you can see also the photo, the materials that have been used for this mixture. Also, as for results of investigation, there were results of physical and mechanical indicators with fly ash and without fly ash. You can see that fly ash constructions don't much less give less indicators than mineral powder. As for physical and mechanical indicators of concrete samples, the situation is the same. So we can see that this light color is with fly ash, dark blue stands for mineral powder. But in our country, there are some impeding factors that don't give us possibility to use fly ash. This is the absence of mandatory state legislative documents and incentives for the use of fly ash. I mean that we could do as Europe does, like the pollutant has to pay, and then during the full scale usage of fly ash and wastes, we would have some cost saving. Also, the ash slag consumption market hasn't been formed. Now it starts to move, but it's not like we desired. The influence of ash residues on all types of road pavement hasn't been sufficiently studied. So we should carry out a lot of other research to understand the gaps in durability. A complete regulatory framework for the use of ash and slag in road construction hasn't been formed. Just recently, in the standard 121, fly ash has been added as a material that can be used for asphalt concrete. And in Ukraine, there was no experience of road construction using fly ash until 2021. So this is the only example that we have. So the conclusion is that usage of fly ash doesn't reduce the physical and mechanical indicators of asphalt concrete. And if we just use fly ash instead of other mineral powders, it will make the situation cost efficient. So I think that we should see what is the exploitation durability of asphalt concrete, and we should make a lot of other research. Thank you so much. Yeah, I would like to say that we have positive experience, and this road that has been discussed, it has some pluses, but we need some time also. So this was about our university usage, how we should use fly ash in the coverage course. So next, our speaker, Mudrichenko Anatoly, will talk about the use of fashion slag waste of thermal power plants in the base layers of road pavement. So I pass the floor to the Anatoly Mudrichenko, Deputy Head of the Department of Roadworks Technologies of State Enterprise Держдор NDI. Good afternoon, everybody. Do you see my presentation? That's great. So today we will talk about our experience in use of fashion slag waste of thermal power plants in the base layers of road pavement. At first, we know that coal is one of the most important primary sources of energy in Ukraine. And after its combustion, we have ash dumps, where we have more than 300 million tons of ash and slag waste. We have fly ash dry, we have fly ash flux, we have fly ash wet. In Ukraine, how do we use ash and slag waste? We produce concrete. It's like 86% of all the ash usage. As for operators of market say, the concrete producers use ash and slag waste products in maximum potential proportion. That's why potential that we have today isn't appropriate here. Also, we can use it in concrete, we can use it in road construction also. So road construction is one of the main sources where we can apply it. So for 1 kilometer of road category, depending on its local conditions and category, we need from 6 to 60 cubic meters of soil, and also much masses of sand for drainage layer and frost-resistant reinforced layer, and from 1 to 5,000 cubic meters of binders for basic courses. Ash that we use in road construction can be used as a part for concrete and cement mixtures of rigid or metal works, and also for some beams and girders of the bridge. And also we have different groups that have different appropriate meanings and different appropriate applications. For example, the second group can be used for construction of basic courses only together with additive of 50% of crushed stone, or after it's binding with non-organic bindings. Third group of slag and waste can be used together with some other additions or concrete just for reinforcement. And all the groups from 1 to 3 can be used for embankment of the road course. Legal basis for the usage of fashion slag waste is quite developed. So we have a set of national standards for technical requirements, technical conditions, as for crushed stone mixtures, as for mineral binders, guidelines, for crushed stone layers, and for embankment of road surface. As for different grinding capacities, there are also different things. There is coarse-grained, medium-grained, and fine-grained material. As for containment and humidity, we also can divide different groups. The first, second, and third one. We have an experience of usage the separated hydro removal fly ash. We tried do it and we tried to make a research because we wanted to see how it behaves itself with mineral binders to provide for different courses of the road. So we provided testing and also the crushed stone and sand mixtures. We chosen the mineral binders with hydro removal fly ash also. We provided and produced the dense and compacted mixtures. We have found 3 compositions of this special crushed stone sand mixture with 20, 25, and 30% of hydro removal ash. After it, we have produced and tested samples. We provided its testing on water saturation, compressive strength, and frost resistance. There are the results that you can see, how the density changes, how this water saturation changes, if we add this or that part of hydro removal fly ash. I also wanted to drive your attention to the fact that all 3 mixtures have been produced and tested, and the results showed that removal fly ash mixtures, as for their physical and mechanic requirements, they meet the standards of minerally binded crushed stone sand mixture, and we can make the following conclusions. Density of material reduces when there is bigger part of hydro removal fly ash. Water saturation goes up if we take more hydro removal fly ash. And also compressive strength changes, elasticity module, and compaction of material. So we have understood that we can use it for road pavement for general roads of 4th and 5th category, for the basic course for general roads of all the categories. It also can be used. The second, or the next, I would say, experience that we have was participation in accompaniment of scientific and technical direction during the construction and updating of the experimental track of road in Kyiv region. It was motorway renovation with cold recycled fly ash. During the design phase, we have conducted different laboratory analysis. We have chosen samples. We measured elasticity modules of road pavement, and we produced 2 different variants of road pavement. The first variant is just an ordinary one. So we have asphalt concrete coverage in 2 courses, 12 centimeters. The second experimental part or option is just renovation of already pre-existed removal using the cold recycling fly ash in 20%, and also then we cover it in 6 centimeter of asphalt concrete. In laboratory, After testing of an already pre-existed road pavement, we chose the grain fraction, how much fly ash should we add. So this was 20%, by the way. Also cut material and cement. We made testing on the 7th and 28th day. The indicators, as for the physical and mechanical indicators, completely meet the requirements of national standards. Technology of how we provided all this. We made the pre-cutting, then distribution of crushed stone, then distribution of fly ash, distribution and recycling, and some other stages. Also, we made different measurements. It was strength after cutting, strength after road material produced by coal recycling technology. We obtained the results more than 200 megapascal that gave us possibility on the 3rd day of the embedment to provide the road with the new course. After 28 days, we made measurements of elasticity module, and the obtained results were good as calculated. Also, we made laboratory experiments, and the results were good. So this track was built in 2021, and now it has been used for more than 2 years. Currently, it can be seen like this, and after visual investigation, we can see that there are no defects, no ruinations on this track. As for results, I can say that the main conclusions can be said about the fact that the usage of ash and slag materials can increase durability of construction of road pavement. Also, very important fact was the reduce of cost for materials, because slag and waste materials cost less than natural stone projects such as rubble and sand. And also the decrease of energy consumption of economy, the usage of areas that can be used, that previously were used as ash dumped, and also the saving of financial resources. That's it. Thank you so much. Thank you.
Можна
Я
презентацію.
виключаю зараз.
Да, будь ласка, виключте. Колеги,
I will switch off my presentation. So, dear colleagues, if you have any questions, we will be happy to answer them. In chat, we see that there are some answers and some useful links that you can use, or maybe you can just copy for yourself. So please be aware of it. Now, I don't see any other questions. It means that we pass to our next speaker. And next speaker will be dedicated to reuse of milled asphalt concrete crush using cold and hot recycling technologies during the road repair with non-rigid coarse surface.
Добре. Тема доповіді повторне використання фрезерованої
Now, the topic is reuse of milled asphalt concrete crumb using cold and hot recycling technologies during road repair with non-rigid road surface. So, the importance of this work is the fact that we see the simultaneous application of different technologies, of recycling technologies. The logic of this solution is matched to the fact that if we apply the cutting procedure, it can go layer by layer, and the part of materials can be applied using hot recycling technologies. I mean the cut milled asphalt crumb of high quality, and all the rest of materials we can use in the framework of cold recycling technologies. We can make it just on the road or in the machinery. All these technologies are implemented in Ukraine.
на їх виконання. Є
There are regulations how to use them. There are implementations and special machinery that can use these. And also there is importance of these technologies that can be used simultaneously. Well, we know that axial load is increasing. For example, before we had 10 tons for X, and now we count for 115 kilonewtons and 130 kilonewtons. Here we must understand that more load there is, more characteristics we need. So the higher is load, the higher is tension. And materials, they undergo more tension. And we must design a construction in such a way to make this indispensable strength. And the strength can be provided only through the width of layers, because the materials we have like preconditioned. So if we see our task as for the rise of load, this task is like goes, so there is calculation, as you can see on the screen, that if we increase from 100 to 130 kilonewtons, it means that we should increase the strength, compressive strength, to 14 centimeters, by 14 centimeters. But if we make a repair, then the strength goes down. It means that we should apply not 14, but maybe 20, 25 centimeters
автомобільних дорог високих
of
категорій.
bigger width. So it depends. We must understand that we need a lot of different materials. What can we say? We suggest this number of material to provide while simultaneous use of hot and cold recycling. Hot recycling technology has also legal background, legal documents and recommendations, guidelines, how to choose the mixture, how to choose technical requirements. And in 2019, there was another like a new standard about regenerated asphalt concrete. This technology isn't complicated. You can see it on the screen, that at first we cut asphalt concrete, then we take this crumb to a special machinery. In this machinery it goes mixed and new asphalt concrete is made. This technology was implemented in Europe, in Ukraine, and it is based on thermal balance. When we give heat to the stone material, then we add the crumb and this shear, so we can state the shear, and then we obtain cut asphalt concrete.
В нормах вони прописані. Якщо в нас не габарит, то є такі драбарки, які дозволяють пофракційно даже нам.
There are also some special crumblers which allow us to save granulated crumb. So milled crumb goes in, and then the mixer mixes it within the indicated amount of time to a certain percent, and then we get the asphalt and concrete mixture. Technology of cold recycling. It's been provided in Ukraine within 20 years. And actually, it's energy efficiency technology, energy effective technology. It's not actually a novelty, but the novelty is that to use several decisions at the same time. So, of course, it's understandable that, first of all, you produce a mixture, and then this mixture can be put to the road, and then according to the proportions, there is a certain amount of binders. It can be a complex binder, or where organics and regular ones like cement are mixed, and then it's densed, and then we have a layer. Complex binder is also used broadly. In Ukraine, it's a bitumen emulsion and cement, and there is also a version of foam bitumen. And also we have more of the mineral binder and complex binder and the less organic one. So now we can say that this complex introduction allows us to do it differently, but here is more organic binder. Now let's look at why it is so, but later on. So here you can see the machinery which is European, what used in our factory. And here you can see the machinery of Poltava factory, and here you can see the norms and recommendations. And also the simultaneous use was considered. What's the combination of the simultaneous use? The method of the hierarchy analysis was used. And the approach is complex. It can be called the concept of 3E, with the economic components, energy components, and ecological ones. Why so? Because you cannot You cannot make prognosis about it all because we do not know how ecological disruptions will influence the environment. We cannot fully define the energy component. And the method of the analysis of the hierarchy through the experts allows to treat this task and try to solve it. So here you can see the factors like energy efficiency and ecological safety and a given value, and then the options. Here you can see the analysis of the method of the analysis of the hierarchy. Here you can see the factor evaluation. There are certain requirements here. And present options that we were considering. Traditional material with asphalt and concrete layers, and then cold recycling layer, and then traditional one, same asphalt and concrete layers. And the third option is when the second layer with the help of the cold recycling was produced. And then you produce a layer where there are more organic components with the help of the cold recycling method. And the third one is the cold recycling layer with the concrete, where there is more concrete. And then the technology is on the road. So we have considered the simultaneous provision of 3 technologies. So what does our analysis show based on the method of the analysis of the hierarchies? So the first option is the least priority, second has the second priority, and the third one has the top priority. So here we gain a little bit in terms of the cost compared to the second one. But these 2 factors like ecology and energy factors are very important here. So thus you can not only project the technologies of the simultaneous use, but you can also ground it analytically. Thank you for your attention. Thank you. You can stop the presentation if that's it. I remind you that you can ask questions if you raise your hand or write it in the chat. And I have to say that a tradition of our seminars is that all the registered participants will have the presentations to their emails. So you will have all the presentations. So now, unfortunately, Mr. Klimenko will not be able to join. So I would like to introduce another person. Victoria Alexandrovna Hudba, the professor. She will be talking about the European approaches to the regulation of the ecological aspects. And the floor is yours. Thank you. Can you see my screen? Yes. First of all, I would like to thank the organizers of this conference for this conference, because the issue of the regulation of ecological aspects of the use of the waste in the road construction is very important. According to European experience, the issue of the approach to the waste, not as a waste, but as a resources which need to be used, is of a paramount importance in our pace to the European Union. So we are thankful to all our researchers who work on these issues, and I'm sure that all the findings that were voiced today will be used. It's actually good for me to present right now, because the previous speakers were already voicing the issues about how to use the waste, like metallurgical slags and other slags. And actually, Vasil was right that these issues are already researched a lot in different institutes. Today we need just a goodwill of people who implement it. As for the ecologists, we might find the common ground here, because now the change of the legislation has been done now, and in 2017 a law on environmental impact assessment was implemented in Ukraine. So it actually defines the main sphere of the cooperation for the changes of the system of ecological management. And of course, a lot of things were mentioned now. It's not only of a concern that there is pollution of big areas, but also pollution of the air and pollution of the water reservoir. So it's a big problem. And according to the law of Ukraine about the environmental impact, it has been done through a certain scheme. I'm not now talking about the procedure of environmental influence report. The peculiarity of the structure is three components. First one is the economical subject. It's the world. It's a huge document which needs to be prepared, and then public discussions, and then this report has been discussed by the community, and after that a decision is made by the authoritative body, like the Ministry of Ecology or some ecological structure of the region, or in any case, these three different structures has their own approach to the environment influence report within the certain road construction, and different problems might arise from that. I will get back to the approaches. In order to accept this report and to start works, a lot of time might elapse, because there is a certain misunderstanding of the procedure of the evaluation. there is a programs of the UN together with the Ministry of Ecology. Two standards were developed, which presuppose a different approach. That's State Standard 9060 and State Standard 9061. And 10 criteria and 60 indicators were developed to be used on the environment influence assessment with the base of the Leopold matrix, which allows to create a certain assessment of the influence. If this procedure is used by the Ministry of Environment, most probably that's the unified approach, which will allow to make a certain decision regarding the waste. While we were developing these standards, we were using the international European approach. The criteria of energy efficiency and resources saving approach was used. So, taking into account that, the criteria of the use of slag materials for road construction or use of slag for certain mixtures and products that are included into this state standard. The use of slag materials, taking into account the energy efficiency, is mentioned there in this document. Actually, there was an attempt to organize the assessment of the influence to the environment, taking into account the use of the slag materials. So here you can see the information on the slide. There are about 30 criteria. So suggested approach presupposes the use of the basic information, and on the bottom you can see the table, which is basic for the use of the matrix of Leopold, and here you can see the coefficient of the influence to the environment. I will not talk about the use of the slag in the road construction. Our department deals with these issues for a long time. Our colleague Nastya Skripovska was dealing with these issues in details, and she was developing the scientific approaches to decrease the level of ecological hazard. But there is also a huge amount of international and national experience, especially in the use of metallurgical slag and ashes slag and so on. 22 centimeters of the road coating can be changed for a furnace slag, and certain indicators are here on the slide. So our task was to try to define how the assessment of the influence to the environment will be changed if we count the use of slag or the no use of the slag. So we took into account the environment influence report, which was done for certain parts of the road. So these roads were constructed with the help of the slag. And here we can see that the minimum amount of slag used there was 20 to 23%. So these were the works which were done with the help of the slag materials, like a furnace slag. The fragment of the expert evaluation of the material allowed to define the full-scale environment influence assessment. So here you can see that while road constructions, if a slag is used, the level of ecological safety went up to 10%. So thus, today, new instruments of the environment influence assessment tools are used, and they allow to use the production waste for this works. Other documents which can be used now, based on the requirements of the European Union, are the requirements of not cost criteria for the procurement. Of course, the economic requirements are used for minimum cost of the construction, but today this series of not based on the price criteria are being developed, which will allow the managers to decrease the price of the construction with help of this criteria. For example, the technical criteria might be to ensure the use of the metallurgical production waste, namely metallurgical slags, for the installation and restoration of the coating layers and the base of the non-rigid road surface. But now, with the Ministry of Economics, with the Ministry of Environment and stuff, there are different changes for this methodology, so I'm not ready to provide you with the final materials, but important is that today, not only technologically, as it was presented in previous report, but based on the ecological legislation, we can use waste resources actually for the road construction. So taking into account the ecological conditions that can be used, for example, the road coating and stuff, if not used, then 0, if at a certain amount, then 5% is added, and so on. So different coefficients are mentioned in the procedures when we choose the contractor for different types of the work. I'm grateful for this opportunity to represent the issues which are important and which are worrisome for the ecologists now, because today we are doing one and the same thing, and I would like to wish us to have our roads of a good quality and that our road will lead us to the victory. Thanks a lot. Yes, of course, let's make your wishes true. Dear colleagues, in fact, If traditionally you have questions, you can ask, you can write them in the chat. So I would like to pass the floor to our next speaker. We have seen the aspects of the use of the waste, and now let's talk about the reuse of beams of span structures during bridge repair. Pavlo Stashuk, please. Good afternoon. Can you hear me? Can you see me? Yes, we can see you, but we're waiting for your presentation. Yes, let me open the presentation. Can you see my presentation now? No, not yet. Please share your screen. Let me find it.
Все добре видно.
Can you see it now? Yes, my report is the reuse of beams of span structures during the bridge repairs. It's a very relevant issue since we have a big number of bridges, which fortunately a lot of them are already repaired. But a lot of them were destroyed too. So the issue of the reuse of beams it's in fact about middle-sized bridges. Since during the combat actions, some constructions are destroyed and some span structures are not and have to be reconstructed. So we have special standards of Ukraine. So the reuse of the materials for the construction of the bridges was developed. So now it is quite relevant for the assessment of the technical condition of the beams and to realize what the constructions conditions of the destroyed bridges. And while we are constructing some temporary passage, the beams can be reused during the construction of the temporary bridges or temporary passages. And also beams can be reused for construction of wooden bridges and for circle roads. And they need to ensure the certain amount of the requirement of the works. The conditions for the reuse of beams have certain requirements. The beams can be exploited in the condition of 1 and 2. Here you can see the state standards as of 2011. So new state standards have the same requirements as they were earlier.
If the girders are in the exploitation state 3 and 4, they should be repaired at first for the improving their exploitation state. And there are special calculations to be made. For temporary bridges, there are special resources, special measurements that should be stated. For example, here the temporary resource should be not less than 20 years. So these are examples of the bridges. The first one I will give only two examples. I think that you will get the information. So here we have the ruined bridge, and out of 72 constructions, 38 were chosen. We evaluated their technical state. During the dismounting process, there were some dynamic influences and some new defects, or the defects that have been present already were detected, even if their nature was not from the explosion blast. Just, I mean, typical alkaline influence or the violation of elasticity of reinforced rods. So these structures were separated. There was culling, and out of these, like more or less 50% of constructions have been culled. There were a lot of hidden defects, as you can see in the bottom right photo, where the girder has a big space, a big cavity, and there is not coating of concrete, because this is the automobile road of the high category, so such constructions defective can't be used. And despite the fact that we have warrant, we have saved also funds. There is another example. We have also some mounted iron concrete girders, 22 meters long. We know their nature, we know their inclination to and predisposition for ruination. You see that they are reinforced by the reinforcement rods that can be corroded, and corrosion will ruin it. So the end girders are more likely to get ruined. But still, there were some cases when the girders were examined, investigated, their technical state has been evaluated, and technical measures were suggested to carry out for their reuse. This also you can see typical defects. You can see the corrosion of the reinforced rods. So carbonization of concrete has been done, and some other measurements have been assessed and evaluated. The tonnage of the span structures have been examined. Out of the defected girders, we evaluated their state, complexive. And also for this temporary bridge, there were some new changes. And generally, as an outcome, we have had quite good temporary bridge that correspond to all the necessary classifications. There was also investigation and research, and there were permission to reuse this bridge that gave us possibility to save some funds for new bridges. Thank you so much. Thank you. You can stop your presentation, your sharing. It's so wonderful because we have two practical examples, two practical bridges, and as far as I understand, half of the girders, they can be used, can be reused. Yes, practically these are. So when we talk about the medium bridges, their longitudinal section is 30 meters. So that's why for medium bridges it's okay, but for longer bridges there will be 3 and more span structures. But during the military actions, we see that at least 2 span structures are ruined, but part of them can be used and reused. So it's very difficult also to find a construction that will have no defects and can be reused. Though a lot of different reparation works can be carried out just to renew the defective girders, so to make a restoration or reconstruction of the structure.
Да, зупинилась.
Yes, thank you. Thank you so much.
Поки що я не бачу питань.
For now, I don't see any questions, and we have another
Це повторне використання мостових балок в якості
bridge. This is reuse of bridge beams as span structures of temporary bridges. Maxim Nichiporenko, the head of Poltava Complex Department of State Enterprise Держдор NDE, will present. So there will be maybe another examples. So please make it full screen presentation and you can start. Can you see it in full screen mode? No, still not, sorry. Okay, let's try again. Now it is visible, yes? Yes. So, hello everybody. Good afternoon, dear participants. My name is Maxim Participants. I am it has already been said, I am the head of Poltava Complex Department of State Enterprise Держдор NDE. And I will talk about reuse of bridge beams as span structures of temporary bridges. I will present the results of research as for quality girders that were used for temporary bridges. The cost of bridge girders, this is 60% of the cost for new bridge, so it can be cost effective. But before, we should provide a culling of these girders to understand which of them can be used, which of them cannot be used. And also the sorting and slinging can be done. So we do geometric measurements, strengths, and elasticity modules, their weights, their other characteristics. The reuse of these bridge girders were possible to make a temporary bridge and to restore it in the village of Bilocerkivka. So, and that's why the transportation and just passage of the transport has been provided through this temporary bridge. The specialist of Poltava Complex Department evaluated and assessed the quality of bridge girders. It was on the way from Kiev to Kharkiv near the village of Bilocerkivka. We stacked, slinged, and inventored and looked through, investigated all the beams and all the bridge girders. We fixed all the defects. And also we used special measurements, special plates just to use to see the width of the fractures. Also use some special tools. All these girders, VP 1645, were in 2018 on the way from Kiev to Kharkiv. They were ruined. Before ruination, they worked for 30 years, functioned for 30 years, and they are shorter. They have 16.44 meters of longitude. You can see also their geometric measurements. The MK18 is their load. So all these girders were stacked and slinged with inventory lining the stacks were from 3 to 5 bridge girders. There were 84 of them. We had to choose 48 of these beams of these girders to make a temporary bridge. So there is algorithm how we assess it. At first, investigate, do visualization, measurements, seeking for defects, characteristics of these defects, then classification table state, the resting resource and feasibility of further usage. And also we use the special list of defects from national standard to understand which of these are applicable. So this ruling is quite old, Ukrainian, but now it has been substituted for DSTU 9181 in 2022. So beams and girders that have first and second level as for Seoul, for temporary bridges, the third state can be used. The fourth and fifth state isn't applicable. So the main defect are fractures. Fractures can be in 3 groups. The first one, groups that don't decrease durability, the second group that decreases durability, and the third group, the fractures that decrease tonnage. Here you can see some typical fractures. The tonnage fractures have second type fractures that you can see in some supporting structures, and the third type is the joint fractures. Fractures that you can see under the number 4, these are in the upper zone. Fifth type is in the expanded zone because of corrosion, and 6 is dedicated to the fractures in the bottom line, and 9, this is like the joint of blocks, but we haven't had such blocks because our beams and girders were in one part. So as for tonnage fractures, these are under number 5 if there are no corrosion sites, number 6 in the lower expanded zone, 7 these are fractures in the edited part, and 8 these are properly longitudinal support fractures. When we chose girders for the temporary bridges, we just examined them visually. If there were some fractures that reduce durability, we understood that they could be taken because we talk about the temporarily bridges. During transportation and loading, unloading works, we used slinging with inventory lining. The slings should be posted and should be placed in a separate, very definite and determined places, so to prevent further fractures. Also, girders can't just be hit one by another. As you can see on the slide, the inventory lining should be used. They prevent affection and contribution to the fractures of bridge girders. Because do you remember that we have had situation in Kyiv when during the mounting process, the bridge girders fell out and there was like an accident. So there should be some technical requirements that should be followed. So 48 beams and girders were stated with the technological state from 1 to 3rd. Only these from first, second, and third type can be used for span structures. The defects are corrosion, reinforced rod ruination, horizontal fractures in bottom line and vertical fractures in upper line. We selected also some other bridge girders in the village Malala-Dyzhine on the road from Sumy to Poltava. So these beams were selected due to dismounting of the bridge from Kiev to Poltava. These were 12-meter beams with 7 rods with the diameter of 18 millimeters. They were stored, you see, near the Malala-Dyzhine village. They were on the asphalt surface in one level on the special wood lining. So a lot of measurements have been done. The cavities, the fractures, and the dimension of the fractures. We made photo of all the girders. We made attributed numbers to these girders. If they were usable, they were transported. Here you can see one of the most widespread defects. So this is a kind of fracture, and it is in the middle of the span structure. So most of these beams and bridge girders were detected. This is because wrong dismounting process, and also the storage had the fact of violation of technical requirements. Under the investigation, we have seen that a lot of these girders can't be used, and only part of them had minimal defects. And now I will show you which bridge temporary niches have been built. This is the temporary bridge near the Karabazivka village on the motorway M12. You can see there are 4 span structures. And now we will show you the technical task and technical project. So here you can see 66.8 longitude with pavements 1.5 meters. And you can see, so all the numbers, all the measurements you can see. The supports are made from metal tubes with diameter of 18 millimeters. There are 4 span structures, 12 beams and girders in cross section, and they have different also configuration and different arrangement just for distribution of the load. There are also special holes in the road covers for special loops for mounting goals. Here you can see the overall view of the temporary bridge. You can see that there are some fences from concrete blocks and girders of span structures. They are not in monolith structure with each other, but the road course is made of iron concrete mixture. So there were used also 90-ton crawler cranes. The third span structure has been started after the force-shore span structure. And also, in addition, there were some special plates, 3 to 4 meters, were made and were laid for distribution of load. So the tonnage of this bridge is 90 tons. Another bridge that I'm sorry, we don't have a lot of time, so I just ask you only general information, so very briefly. I need 5 minutes. I need, so it's not, you don't have just to tell about the schemes, because there are not many like bridge specialists. So here we see 2 facades, the black and red. Red is the main one, and the black one is 7-span structure bridge. So some of them are made of reused bridge girders, some of them are used from other constructions. Here you can see cross-section of one of the span structure. You can see how it looks like. And they are just united into pegs with special binding techniques. Also, you can see the construction, how the bridge canvas was under the designment. So these plates are compacted by special rods and reinforcements. Now we see the cross section of the end span structure. So 6 girders that were selected for usage, they are here, but they were not enough. And contractee took some other girders from his warehouse in Kiev. And span structure has been diminished from 12 meters to 9 meters. 3 meters were used for transitional plates. The mounting was like here, so it was like you can see that the overall tonnage was more than 50 tons. On the left photo, you can see that these girders are stated, and they have tonnage 25 tons for one beam. And on the right, you can see span structure of the temporary bridge in the process of construction works from L beams. Here on the left, we can see crossbar and support. So crossbar is made from L beams, and it was constructed near the existing bridge that you can see on the right. That's why we see that the bridge girders with the longitude of 12 meters and 1645 meters can be used for reusage, especially for temporary bridges. Because after long durability, years of duration, they still have good characteristics and can be used. So practice shows us that we should drive our attention to different stackings and slingings of girders. Thank you so much. Thank you. Thank you, Maxim. You can switch off your presentation. So today we have already finished our program. As you see, we have analyzed a lot of different materials, reusage of them, wastes, and other parts. So please, Artem, I give the floor to you. Thank you so much for today's facilitating, Mr. Igor. Thank you to all the participants, to all the colleagues who found strength and time to stay here with us during all the day. I see that now we have 151 participants. And colleagues, you see that today there were very different speeches dedicated to different topics. I'm sure that we will continue this good tradition of annual events like this. So, dear colleagues, if you have any speeches, any presentations, very interesting ones, we invite you to collaboration, to joint work. So we would like to have to make some conclusions. And I would suggest I will make some suggestions that I have noted for myself, and maybe my colleagues will add something. So from the very beginning, we should actively continue work on different levels. As for the change of the approach to the use of waste, and we should perceive waste as a resource, potential one that can be used in different courses of road payment. They should meet legal requirements, construction norms, and we know that we have also special accompaniments, scientific and technical, but colleagues, we should favor this process. This is the fact. And for example, from the point of view of clients, that during technical task for designing, please foresee optional designing, and it is also desirable to have an option with local materials application or waste application. So those variants that can decrease the cost of construction. We understand clearly that when recovery starts, and even now, the cost efficiency is really very decent, relevant, and paramount. So please, dear colleagues, when you do optional designing, calculate everything and foresee the possibility of application of different waste types or reuse of material. So the next suggestion is to continue work for improvement and other legal framework as for waste reuse and byproducts reusage, especially through elaboration of national standards in compliance with international and regional standards. This is very important. This is very important for us as ministry and for the Agency of Restoration and for all the other scientists. We also suggest clients to continue research and scientific and technical accompaniment where the waste is used. This is also a very important element that we must do. We understand, colleagues, that this is very important to monitor such plots that have been built with the waste usage. So this is also a very good guideline. We should show concrete practical examples how the road payment has this or these materials. So we can do it in a very calm way by using our innovation portal. You understand that there is such resource. I have told you about it when we started our conference.
Отже, колеги,
So, dear colleagues, of course, we hope that you will actively help us in this process. And of course, we invite all of you to cooperate with us. So if you have something to add, if anyone has something to add, if you have proposals that we have to voice, please tell us. Just a minute. I actually liked when Mr. Tomasz Cegielski said secondary first. That actually the approach that needs to be as a conclusion of our seminar. You actually need to take into account the secondary products in the first place. Thank you. Maybe other colleagues have some comments or wishes. We will be glad to give you the floor. You can raise your hand or you can write it in the chat. Okay, I do not see any comment. So then I am thankful to all of you for this work today. I can remind you that the video recording and the presentations will be sent to your electronic addresses. And the one you used for registration. And we are inviting you to our other events that will take place. For example, tomorrow there's going to be a big international conference which will take place in Ivano-Frankivsk. It's going to be in hybrid format, so you will have an opportunity to join it even online. So if you have not registered there yet, you can do it. So I would like to thank all our colleagues from the abroad who were with us today. We are thankful for your valuable experience, and we hope for active cooperation in the future. And we are ready to implement the best practices and innovations. So thanks a lot to everyone for this work today, and see you soon at our platforms.